Hello.
Yes, Ray sir, please go on.
Yes, sir. We'll start. A very warm good evening, galaxy of intellects, invited guests, professors, research scholars, and students. I am Assistant Professor Sri Shinde, Department of Mechanical Engineering, Pimpri Chinchwad College of Engineering, Pune. It's a matter of immense pride to talk here before all of you this evening for inauguration of 6 days online ATAL Faculty Development Program on electrical vehicles, technology, power system, energy management, testing, and certification. To set the tone, let me share a quote. Talent and skills are the crops that are nurtured, groomed, and given all possible opportunities to grow and bloom. This perfectly encapsulates the essence of today's program, a celebration of lifelong learning and pursuit of excellence. It gives me immense pleasure to welcome our esteemed participants who have joined us from the various places to be part of this transformative journey. This training program is not just an event, but a platform to enhance skills, share knowledge, and create possibilities in the electrical vehicle technology. It is rightly said, education is the passport to the future, for tomorrow belongs to those who prepare for it today. With this training, we aim to prepare ourselves for brighter tomorrow. To officially mark the beginning of this event, I would like to invite our esteemed program co-coordinator, Dr. Sagar Wankhede sir, to deliver the welcome address. Sir has been the driving force behind this program, ensuring every detail is planned to the perfection. Over to you, sir.
Thank you, Shri sir. And good evening all. I am Sagar Wankhede, working as an assistant professor in mechanical department and co-coordinator for this program. Warmly welcomes you to this program. So good evening all, respected dignitaries, esteemed faculty members and enthusiastic participants. It is indeed an honor to be here as a co-coordinator addressing the 6 days online FDP sponsored by AICTE ATAL on the fascinating and timely topic of electric vehicle technology, power system, energy management, testing and certification. So we are gathered here during a pivotal moment in a history as the world faces challenges like climate change and energy depletion. EVs represents a beacon of hope. So this program is not just about technology, it's about shaping the future of sustainable transportation and empowering India to lead this revolution. So we have total 13 expert sessions has been planned. The main goal of this FDP is to provide a well-rounded understanding of EV technology and its ecosystem. By participating in this program, you are contributing directly to India's sustainable transportation vision. This FDP is not just a learning opportunity, but it's a stepping stone towards a sustainable future. So I think by the end of this 6 days program, so you will emerge with skills, insights, and inspiration to contribute meaningfully to the EV ecosystem. So thank you once again for your participation, and I wish you all an enriching and transformative experience over the next 6 days. Now I request our beloved HOD and coordinator for this FDP, Dr. Praveen Kai sir, to take over this session. So, Kai sir?
Yes, sir.
Okay, sir.
Yes, good evening all. Respected Chief Guest, Dr. Govind Kulkarni sir. Director, Pimpri Chinchwad College of Engineering, Pune. Then esteemed speakers, my dear colleagues and participants. Now it is a matter of immense pride and privilege for me to welcome you all to this AICTE Training and Learning Faculty Development Program on the theme of electrical vehicles, technology, power system, energy management, testing and certification. As a head of mechanical engineering department, I extend my warm regards to each one of you and express my heartfelt gratitude for your presence and participation. The ATAL FDP is an initiative aimed to empower educators, equipping them with advanced technical knowledge and innovative pedagogical approaches. By the end of this FDP, I am confident that you will live with fresh perspectives, actionable ideas, and a renewed enthusiasm to contribute meaningfully to teaching, research, and professional developments. As the head of Mechanical Engineering Department, I am delighted to host this initiative, which resonates deeply with the aspirations and objectives of our department. Today, as we embark on this journey of learning and innovations, I take this opportunity to introduce the remarkable achievements of ongoing endeavors of the Department of Mechanical Engineering. The Mechanical Engineering Department is a cornerstone of our institution, committed to academic excellence, cutting edge research, and holistic development of students. With a legacy of producing technically adept engineers, we aim to equip our students and faculty with the skill and mindset necessary to excel in the ever evolving fields of energy and technology. Now, this department is established in 1999. We have started mechanical engineering with intake of 180. Then the PG courses we have started on 2012 and PhD in 2017. Now our PG courses, PG programs are NBA accredited. 4 times it is accredited: 2013, 16, 19, and 22. Now total number of faculties in the department is 46. Out of that, 28 are PhD completed and 16 are PhD pursuing. The total strength of the department is 724. The department offers a comprehensive curriculum that blends theoretical foundations with practical applications. The key highlights include the state-of-art laboratories, industry-relevant curriculum, and project-based learning. These are the different additional created facilities. That means these are the sponsored laboratories in the department. Model-based system engineering lab, Capgemini, then Dassault system, MQC for Baker gauges and others. The research is the lifeblood of our department. We focus on interdisciplinary and industry-driven research to address contemporary challenges. We actively encourage our faculty and students to publish their findings in reputed journals and them at national and international conferences, strengthening our research impact. Now, these are the ongoing research projects. Almost 8 to 10 projects are there, which are special projects, and particularly modular development of conventional vehicle into electric vehicle under CIRO, sponsored by Packwell Gasket Private Limited. So these are our ongoing projects in the department. Then collaboration with industry is a priority of our department, ensuring that our students and faculty stay at the forefront of technological advancement. Few of our initiatives includes the Memorandum of Understanding, which partnering our leading automotive and energy companies for internship, joint research, and knowledge exchange. The collaborative projects working with industry sponsored project is like area of EV, electric vehicle driven design, battery optimization, and testing protocols. These collaborations have provided our students with valuable exposure and our faculty with practical insights, creating a robust academia industry ecosystem. In student development, we have different collegiate clubs. The holistic development of our students remain at the core of our mission. Our initiatives in this direction include the clubs, collegiate clubs. These are our different collegiate clubs. Through these activities, department facilitates internship programs, entrepreneurship supports, skill enhancement programs. These efforts have helped our graduate secure excellent placement and pursue higher education in premier institution worldwide. So these are our achievements in the department. Now these are our major recruiters of the department. These are major recruiters. The topic of this FDP, electric vehicle technological power system, energy management, testing and certification, align perfectly with our department's commitment to addressing the challenges of sustainable and eco-friendly mobility. As a department, we are not just passive observers of electric vehicle revolution. We aim to actively shape it through academic excellence, research, and collaboration. In conclusion, I would like to emphasize that programs like these are instrumental in fostering knowledge exchange and creating a platform for collective growth. I encourage all participants to take full advantage of the session, engage in meaningful discussion, and explore opportunities for interdisciplinary collaboration. Together, let us drive innovation, create sustainable solution, and contribute to building a cleaner and
इतने सारे
greener.
लोग कनेक्टेड है अल्लाह मैं और यू नो कैमरा कैसे
Once
ऑफ
again,
कैमरा ऑफ
I
करो
extend my heartfelt
हम्म।
gratitude to AICT, our institution, and all the speaker participants for making this program possible. Let's make this FDP a resounding success. Thank you very much. Over to Shreyas. Hello, Shreyas.
Yes, thank you, sir. Thank you very much. All the participants are requested to ensure that they are on mute. All the participants, please ensure that you are on mute. Thank you. Thank you. Nothing great will be achieved without great men. And men are only great if they are determined to do so. This determination was with us due to our great motivator and mentor, Head of Department Mechanical Engineering, Dr. P.R. Kale sir. Thank you very much, sir, for your wonderful address. The fragrance of a flows spread only in the direction of wind, but the goodness of a person spreads in all the direction. I now have the privilege of inviting our respected director, Dr. Govind Kulkarni sir, to share their thoughts and inspire us with their words. Sir has always been a strong advocate for innovation and professional growth, and their vision has been instrumental in shaping programs like this. Please join me welcoming Dr. Govind Kulkarni sir.
Is being recorded.
Thank you. Thank you, Shinde sir. And I warmly welcome all the participants of the ATAL FDP or Electrical Vehicle Technology. I really appreciate the enthusiasm of joining to the course at 6 o'clock, which is fag end of the day. So it is apparent from your enthusiasm that you are deeply interested in the topics. Thank you very much for joining, and thank you very much for joining at Pimpri Chinchwad College of Engineering. I warmly welcome you at PCCOE. You will definitely benefit from such a course of 6 days because I have a great expertise like Dr. S.R. Wankede, Dr. P.R. Kale, C.S. Shinde, and all here who are passionately working in the electric vehicles technology. The development of a country is indicated on the energy consumption and energy security. When we talk of India, the energy security of India is not that strong because we are importing lakhs of crores of rupees of crude every year, which drives our transportation sector. So, as Dr. Vankile mentioned, there is a dire and urgent need of going for a sustainable solution in the transportation sector. 60% of the fuel consumed which we import is in the commercial transportation like diesel and maybe remaining in petrol. So this electrical vehicle technology is urgently needed to be developed and matured in India. And a lot of efforts at the Indian level are going on. Lot of institutes are working, and we are also working. One or two issues which we are focusing on is the accelerated charging of the batteries, the vehicle batteries, has been a crucial point. Like thermal management, first, accelerated charging of the batteries is one issue. Second, thermal management of the batteries. And third, the resource which we are using for charging the batteries. Now, these are the issues to be addressed in a technological way. And then a lot of brainstorming is needed at all India level. And who knows who will come up with the innovation and the breakthrough. So we are tapping the possibility of getting the breakthrough. As regards the energy resource for charging, it is not wise or maybe connected to the common sense that you use the electrical vehicle and charge your vehicle using the electricity, grid electricity, because grid electricity uses coal finally. So it cannot be a sustainable solution. On the other hand, if you use a solar charging station, if the charging station is accumulates if it the charging station accumulates its energy through solar, then it would really be a sustainable solution. So I think on these three issues the participants will have a provocative research and then provocative discussion in the lectures to come. There are a lot of experts who will be sharing their ideas and the technologies in testing and certification to come. I again wish all the participants the best knowledge through this ATAL FDP, and then I congratulate the organizing team for such a wonderful organization of the course. Thank you very much, and all the best.
Thank you so much, sir, for those insights, motivating words. With this, we officially inaugurate 6 days online ATAL Faculty Development Program on electrical vehicles, technology, power system, energy management, testing, and certification. Let us all dive into the journey with enthusiasm and an open mind ready to learn, and relearn. Few important instructions for the participants before starting the program. As we
406, Mr. Syed.
Mr.
Please
Sayyad,
mute
you are
yourself.
requested to mute yourself. All the participants, please ensure you are on mute so that there will not be any disturbance throughout the program. And that's why I'm reading few of the important reminders for all the participants. As we embark on this enriching journey together, we would like to share few important points. Our next expert speaker has already joined, so let me start the session quickly. Instructions. Your active participation is key to making this training the most effective. Please ensure that you'll attend all the sessions regularly on the time. This will help you stay on the track and fully grasp the concepts covered. Learning is the most effective when it's interactive. We encourage you to participate actively by asking the questions, sharing the thoughts, engaging in the discussions. Your feedback is invaluable to us. Please take a moment to fill out the feedback form shared after each session. Kindly ensure that your microphone is muted during the session unless you are speaking. This will minimize the disturbance and maintains the focus of everyone. Make sure you have a stable internet connection and your devices are ready before the sessions. If any assignment or task is given, please complete on time. Let's respect the schedule shared with you. Join promptly at the designated times and stay in the session until they are concluded. Use this opportunity to connect with the fellow participants and share ideas. Thank you. Wishing you everyone a successful training ahead. As we move forward, let us remember the words of Albert Einstein: creativity is intelligence having fun. Let's channel, let's channel our creativity and intelligence into the sessions and activities ahead. After each session, the feedback link will be shared and it will be only available in the chat box. So make sure that you are filling the feedback form from the chat box. Link will not be shared in the WhatsApp group. So this is common information to all. I again request all the participants to be on the mute. With this, we'll close the inauguration program. Heartfelt thank you to our respected director, Dr. Govind Kulkarni sir, for your unwavering support and guidance. Your words have always inspired us to aim higher and make most of it. I also thank Head of Department Mechanical Engineering PCCOE, Dr. Pavin Kale sir, for being a pillar of strength and encouragement for this event. For today, we have planned these two sessions. Session number 1, Electrical Vehicle Innovation, Developments and Regulatory Standards by Mr. Manoj Desai sir, Deputy Director, the Automotive Research Association of India, will be immediately starting with this session. And after that, we have second session scheduled, which is session number 2, Design and Development of Battery Pack for Four-Wheeler Electric Vehicles by Assistant Professor Shweta Patil. And this will be after the session number 1. So session number 1, Electric Vehicle Innovation, Developments and Regulatory Standards by Mr. Manoj Madhukar Desai sir. I'll quickly introduce sir to all the participants. He is presently Deputy Director of Automotive Electronics Department of the Automotive Research Association of India, ARAI. He is graduated in Electronics Engineering from Walchand College of Engineering, Sangli. Equipped with 25 years of solid professional journey, he has spent over 23 years at ARAI. As a Deputy Director, he is responsible for certification testing of electric and hybrid electric vehicles, assessment of electric, hybrid electric vehicles for government incentive scheme, establishing testing infrastructure for electric and hybrid vehicles, formulation of automotive industry standards for electric, hybrid electric, fuel cell vehicles, formulation of automotive industry standards for intelligent transport system, cyber security and OTA update, certification of automotive cyber security and software update management system. Additionally, he looks after evaluation testing of automotive electronic system and vehicles for electromagnetic compatibility. Being an active industry member, he has devoted significant time in industry research and has published many research papers. So with this introduction, now I hand over charge to Mr. Manoj Desai sir. Sir,
Good evening, sir. Good evening.
I'll stop sharing the screen and you can share the screen.
So is my screen visible in
Yes, sir.
PPT form? Yeah.
Yes, sir.
Okay.
Screen is visible in full screen mode. Okay. Over to you.
Yes. Yeah. Good evening, all, and thank you very much.
Visible, Professor. Visible.
Hello.
Yes, sir.
So good evening, and thank you very much for inviting us. So I attended the inaugural function, and Dr. Praveen and Dr. Govind rightly mentioned the challenges in front of EV industry, and that's why. So I will start with some of the regulatory requirements in India and what we exactly do. So this is outline of my presentation. So I will cover electric vehicle certification standards. I will cover traction battery safety requirements, hybrid electric vehicle standards. There are standards for converting older vehicles. Then there are some new proposed requirements. There are certain regulations or charging stations and our center of excellence. But before starting my presentation, few slides I will go through what we do in ARAI and certain few information details about the present electric vehicles in India. So we are established in 1966. So this is more than 50 years of organization. We are an autonomous body under Ministry of Heavy Industry, and our all certifications or rules or requirement comes under Ministry of Road Transport and Highway. So we are attached to both the ministries. So our headquarters is in Kothur, Pune. We have 2 more locations in Chakan, where some additional facilities are there. So we have almost 850 plus permanent employees, more than 1,000 crores of investment, and almost all types of laboratories are there, including powertrain, exhaust emission, passive safety, safety and homologation, vehicle evaluation, materials, automotive electronics, structural dynamic, NVSC. So almost everything related, right from the components of the vehicle till the entire vehicle, including 2, 3-wheelers, bus, trucks, and construction equipment vehicles, agriculture tractors. So all the test facilities are available with us. So basically, ARI does a few important tasks. So we formulate standards for India. So those are automotive Indian standards. So those AIS gets notified by the government of India, and then it becomes a mandatory requirement for all these vehicle manufacturers as well as component companies to go for the certification. Then, so that certification process is called a type approval or homologation, you can say. We do a lot of technology development, lot of R&D projects for the industry. We don't manufacture anything, but whatever technologies developed, so those we hand over to the industry so that they can take it forward. We do a lot of consulting activity. We have our own academy, like we have tie-ups with certain colleges in India, and we run some MTech programs. We do proficiency improvement programs for the industry professionals on the new technology. So this is basically a regulatory mechanism in India. So as I mentioned, there are 2 ministries mainly involved. So most of the rules for vehicles comes under the purview of Ministry of Road Transport and Highway, that is MRTH. And there are Ministry of Heavy Industry who takes care of promoting this electric vehicle, like several incentive schemes are run by MOI, Ministry of Heavy Industry. There are other ministries also. There are certain rules, for example, battery recycling or certain pollution activities come under different ministries. But primarily, MRTH is responsible for notifying the standard. And ARI,
எனக்கு அந்த இது போட்டா அது எப்படி தெரியும் chat boxல அந்த லிங்க் போட்டா
coming to the
அங்க
standardization
பாரு இந்த 3 டாட் கிளிக் பண்ணிட்டேன் சரி
can you please mute?
போன பாத்துட்டே இருக்கணுமா இவங்க போட்டானா குப்பி வச்சு அப்ப அது எத்தனை மணிக்கு வந்து எனக்கு தெரியல 8 மணிக்கு ஒரு செட் முடியுது 8 8:30
Hello, Goila. Who is Goila?
8 மணிக்கு ஒன்று 9 மணிக்கு ஒன்று சரி 8
Hello.
Raska sir, please mute 5-1.
Yeah, okay. Thank you. So when it comes to the standardization, so there are 2 apex level committees are there. One is Central Motor Vehicle Rule Technical Standing Committee, which is chaired by Joint Secretary MRTH. And there is a committee called Automotive Industry Standard AISC, which is chaired by Director ARI. And ARI handles the entire secretariat. So both these committees formulate the standard, and the Ministry of Road Transport notifies this. And once I said once it comes as a notification in Gazette, then it becomes a mandatory requirement for all these OEMs as well as component companies. Now, there was one report published by Niti Aayog, India Leaps Ahead, in 2017. And they had predicted if we go with shared electric and connected mobility and autonomous this case, then almost 64% of the anticipated road-based mobility-related energy demand can be reduced, and almost 37% of the carbon emission can be reduced by 2030. So this was the starting point for government to decide many policies. But if you see the initiatives taken by our ministry, almost in 2011, the National Mission on Electric Mobility, the group was formed, and they published NEMMP 2020 report in 2013. And as a part of this promotion for electric vehicle, in 2015, the government came with FAME India scheme, which was a incentive scheme to promote electric vehicles. And from last 9 years, this ministry is running different incentive schemes. So at present, you can say there is a PM E-Drive scheme which is launched from April 2024. There are schemes for production-linked incentive in automobile to manufacture electric vehicles as well as components of the electric vehicles, and there is a production-linked incentive scheme for advanced cell chemistry. Like some companies are interested in manufacturing lithium-ion cells in India. And for that also, there is a scheme called ACCPL. What is an electric vehicle? If you see the definition in motor vehicle, so motor vehicle says that battery operated vehicle means a vehicle intended for road use, powered exclusively by an electric motor, whose traction energy is supplied exclusively by traction battery installed vehicle. So this is a notified definition of electric vehicle in motor vehicle. Now, if you see the energy flow, so typically in any electric vehicle, you have a different kinds of battery chemistries are there. Nowadays, lithium ion is prominent. Earlier, when we started in 2005, lead acid battery were used. So you have a energy source, you have a motor controller or inverter, a traction motor, which is connected to the wheel. So this is how the energy flow happens. And these motors allow a regeneration also, like certain conditions in braking, the electricity, the motor will act as a generator, and that electricity you can put back into the battery. So most of the vehicles, they use this regeneration feature also. Now, typical components mounted on the vehicle. So it has onboard charger. Most of the vehicles are coming with onboard or a portable charger outside. Motor inverter. There is a vehicle control unit is also there. So which is a supervisory control, because sometimes motor inverter is just power electronics. So in addition to that, VCU they fit it. There are thermal management systems for the motors as well as battery pack. Then there are DC-DC converters, auxiliary battery pack is there. Then traction motor, transmission, battery BMS, and the modules packs are properly packed in the vehicle depending upon the vehicle dimension. There are high voltage distribution box. There are certain safety devices such as isolation monitoring devices are also fitted in high voltage vehicles. So working, if you see the working voltage, there are vehicles with 48 volt DC, 68 volt DC. So mostly two-wheelers or three-wheelers, they run on 48 volt DC or 60. Earlier days, even a small car was designed with 48 volt DC. But nowadays, two and three-wheeler vehicles are 48 volt or 60 volt. And mostly car category they have shifted 350 to 400 volt. And bus or trucks, they are 650 to 750 volt DC. So something above 60 volt DC is where electric shock chances are there. So certain additional safety requirements are there. Now, different motor technologies are used. Earlier, if you see the older generation electric cars, they had a AC induction motor, almost 30 kilowatt of AC induction motors are there. But most of the nowadays high performance vehicle which you see in the market, they go with DC PMSM motor. And in case of two-wheelers, still there are hub motors, there are PMSM axle motors are also there. But quite low cost two-wheelers, you will find the hub motors are also there. Even in electric bus, one of the model, they had a hub motor in both the wheels. So that design is also available. But mostly these are nowadays DC permanent magnet motor with brushless design. So these are typical controllers. In case of car or bus, a bigger controller is there depending upon the power requirement. and those are with water or glycol cooling, liquid cooling. With liquid cooling, it comes, so it has inlet and outlet. Typical two-wheelers, a smaller controller you can see, which is a natural air-cooled controllers are available. So different varieties depending upon various design of the OEMs is available. If you see lithium-ion cell, so there are different form factors available. There are cylindrical cells with 18650 or 21700 kind of geometries are available. Most of the companies has cylindrical cell. There are prismatic cell also, which is a bigger one like a diary, where packaging point of view it is good one. Then there is a pouch cells are also there, like which is not a hard body, but so you can pack 2-3 cells together in a plastic cover, and such types of cells also you will find in various vehicles. And different chemistries are there. Lithium iron phosphate was very dominant in say 2009 to 10-15, where it was very stable cell from thermally point of view. So most of the buses or cars or two-wheelers were with LFP chemistry. But nowadays, if you see, because of energy density, mostly companies are using NMC or NCA kind of cell in India. If you see a battery pack, you have a good session after this on a battery pack. So typical battery pack has a cell. Cells, they build modules out of that cell, and such modules coming together makes a battery pack, which has a master slave kind of BMS inside it. So depending upon size of the vehicle and kilowatt hour capacity, so they will have different modules or cells coming together. They form a battery pack, and if it is a higher energy capacity battery pack, then it might need a liquid cooling. So accordingly, cooling jackets are provided inside the battery pack. So nowadays, all these battery packs manufacturing happens in India. Only cells are imported. The rest of the components, even BMS manufacturing and integration of BMS pack is done in India. Even in Pune, there are many companies who are making battery pack from importing cells and supplying to the Indian companies. Now looking at BMS, so BMS basically takes care of the charge discharge cycles of the battery and the safety margins decided by the designer. So since you might have seen lead acid battery, which is there in our car, there is no electronics to manage its charge discharge, because that way it is much safe. Even it is overcharged, most of the time it may not explode also, or that is what we use it. But in case of lithium ion, you have to operate the cell in a green zone, so you will have to maintain the upper top, the higher voltage which will be used to charge, as well as the discharge voltage. So you need to operate the cell in a proper band, and that is why a battery management system circuit is there, which keeps on monitoring each cell charge conditions, each cell's state of health condition, and accordingly it gives warning to the user and ensures that the charging is connected at a proper, when it reaches, the battery reaches a proper voltage, and the vehicle is disconnected whenever the battery reaches a lower region of discharge, so that an appropriate warning it gives to the user, so that you can charge the battery. So that is the main function of the BMS, and it is very much required for safety of the battery pack. Now, if you look at thermal management system, like as I said, most of the battery packs are coming with liquid cooling. So this kind of systems are integrated in the battery pack, or it can be part of the vehicle, which will be a common cooling circuit for the motor as well as battery. So this will take out the heat from the cells and ensure that the cell temperature remains within a proper band, where it will give the maximum capacity as well as life of the battery. Otherwise, if the cooling is not maintained, your battery may degrade fastly, and you might need to replace the battery. As well as there are chances, because of this heat generation, some thermal runaway might happen in the cell, and which may the single cell might catch fire, and it will because of that single cell trigger explosion, the thermal propagation might happen, which will explode the entire battery. So that is the reason battery thermal management is important. So it is available in cars and buses. Mostly 2 and 3 wheeler battery packs are coming with naturally air cooled. Hardly one or two companies are trying to have a oil cooled battery pack. Otherwise, say 2 to 4 kilowatt hour capacity battery packs, they are coming with natural air. But nowadays there are motorcycles which are coming with almost 11 to 12 kilowatt hour battery capacity. It's a huge battery capacity, like a three-wheeler vehicle.
Sir, I have a doubt, sir. Can I ask?
Yeah, please. Yeah, please.
Sir, in electric vehicles, in the lithium battery, what is the limit for the temperature, sir? The temperature should not exceed in Celsius. Is there any range? Thank you.
Yeah. So every cell manufacturer, the cell manufacturer defines the range for the cell, which is a green zone, like what should be the lower and higher temperature. And accordingly, the OEMs or the battery manufacturer, they design their battery pack. So typical range will be around 40 to 50 degrees Celsius. It should not exceed more than that. Uh, 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 and above that, there should be warning. So even if you see our standard, we have limited to 60 degrees Celsius, the warning must be there. If something goes, battery pack temperature goes above that, there should be warning to the user, so that he can park the vehicle and watch if any issues or errors are there. So mostly operating range, you can say 20 degrees Celsius to 45 to 50 degrees Celsius, not beyond that. So that is defined by the cell manufacturer. Even cell datasheet, you will find the degradation of the capacity based on the temperature increase also. So depending on the designers will design their BMS to control that temperature upper and lower limit. Yeah, thank you.
Thanks a lot,
Then,
sir.
yeah, then there are state of charge indicators in the battery, which is a mandatory requirement. So like our mobile phone, which shows the battery, how much batteries remain. So similarly, in vehicles also on dashboard, you will find a SOC either in terms of a bar graph or direct digital values. So this SOC calculation happens in BMS. So it is not mostly it is not like a open circuit voltage based calculation, because it will not give the correct value. So that kind of mechanism is okay for a lead acid kind of battery. But lithium ion, more complex algorithms like Coulomb counting are used, which will keep on measuring the charge input to the battery and keep on counting how much charge is taken. Based on the calculation, it will show you the state of charge, like rated capacity with respect to the remaining capacity in the vehicle, and it will show you. So these are typical components, like there are DC-DC converters are there, because high voltage battery packs are used in vehicles, but other auxiliary devices like lighting devices or music system or any other lamps, those runs on 12 volt or 24 volt. So you need a DC-DC converter, high voltage to low voltage. You might be using a auxiliary battery like 12 volt auxiliary battery to wake up the BMS and all. So that battery also needs to be charged, because there is no alternator in this kind of vehicles. Like ICE engine vehicles, your engine is running a alternator, and alternator is charging a 12 volt battery pack. So this kind of thing will not be there in this vehicle. So you need to charge your auxiliary battery and supply to auxiliary loads by a DC-DC converter, which will be taking energy from your high traction, high energy, high voltage traction pack and converting into the lower voltages. Then there are isolation monitoring devices, mostly in high voltage electric bus, they use it. So in case of any fault is there, it will indicate to the driver, or it will reduce the power of the vehicle. There are power distribution or voltage distribution boxes, like connecting battery pack to the motor inverter, connecting external charger to the battery pack. So for this distribution box is required, and mostly high voltage, it's mandatory to use orange color cables with a high insulation, and special connectors which are IPXXB or D compatible. So even a human finger, you can't touch to the high voltage portion once it is connected. So that gives a safety to the end user, and this safety is very much required for the end user, as well as the as well as in case of accident, if any authorities come to the help. So those also for them it's important. Otherwise, when the electric vehicle meets an accident, there are chances that high voltage might appear in surface metallic parts of the vehicle, and any early help people might touch such portions and get an electric shock. Now, the most of these vehicles comes with a telematic devices. So there are applications like value-added services these companies offers. One is they can offer like where the vehicle is parked, what is the energy efficiency of the vehicle, how many times it is charged, as well as this kind of data is very much helpful to the OEMs also, like what is the pattern the user uses the vehicle, what is the upper temperature it goes in a cell, is there any degradation, is there any lower discharge or depth of discharge is more. So such kind of parameters the OEMs keeps on monitoring. So they fit telematic devices which monitors the location as well as certain important parameters of the battery and keeps on sending it to the server. And there they can have some data analysis and give some value-added services to the end user, as well as OEMs can draw certain understanding or usage pattern, and depending upon they can modify their design. Typical charging station, if you see on left hand side, this is a offboard charger. So this is a DC charger. So entire power electronics is inside it. So it has a cable, a proper plug or gun, you can say. These charging stations are typically 100 kilowatt, 150 kilowatt, 200, or nowadays 350 to 400 kilowatt charging stations are also there, where externally you can charge the vehicle. So directly you are feeding DC required voltage to the vehicle. There are onboard chargers of the vehicle, chargers fitted on the vehicle, which you are always carrying along with the vehicle. So those are AC chargers. So externally, through electric vehicle supply equipment, you are giving a AC supply, either 230 volt AC or 415 volt AC, three-phase AC, and that will be converted locally to DC voltage and vehicle will be charged. In case of 2 and 3 wheelers, those are portable chargers. You can say these are normally kept in a dicky, in vehicles dicky. So these are very small chargers like our laptop charger. So those are called portable or offboard chargers. So all these kinds of chargers you will find in vehicles, right, ranging from 2-wheelers till electric bus and trucks. So there are different types of charging guns and protocols available worldwide. So first is a CHAdeMO, which is a Japanese connector. In Japanese car, this is available. So in middle one is a GB/T that is available in Chinese cars, Chinese vehicle. And the third one is CCS2 or Type 2, which is there in Europe. So you can see that geographically different connector and protocols are used. In US also there is a different connector. Those are Type 1 or CCS1 connector. Tesla uses their own proprietary connector. But as an Indian government, we have gone for CCS2 and Type 2, which is a European one. So we have removed this GB/T and CHAdeMO. We will not be allowing these kind of connectors or protocols in India. So we have maintained uniformity in line with European connector. So most of the Japanese companies or Chinese companies who will be selling the cars in India, they have to go for this Type 2 or CCS2, so that uniform will be there. So if the connectors are same, anywhere a user in public locations can charge this kind of vehicles. Now coming to the standardization or certification. So when it is started, so as I said, the different committees are there. So these committees, in 1999, they decided we should have standards for electric vehicles, and they form the committee of industry members from SIAM. SIAM is a Society of Indian Automotive Manufacturers, it's OEM society. ACMA is a Component Manufacturers Society, and test agencies like ARAI, VRD, and the government. So these committees under the chairmanship of ARI started working from 1999. So 2003 they published the first standards, and 2005 onwards Ministry of Road Transport they adopted and notified the standard. So 2005 onwards we started certifying electric vehicles as per the standard, and these standards we continuously revise it in 2015, 2020, 2020, 2022. We have revised and tried to maintain the standard in line with global requirement. So 2003 or 2005 when we were working, there were only 2 to 3 vehicles were there. Those were 3-wheelers basically, and some pilot projects were being done by 2-3 companies, and certain vehicles they had introduced nearby heritage sites. So those vehicles were working on lead acid batteries. So it were not so popular or commercially not available to the end user. But 2007-8, some 2-wheelers started coming, and then onwards, after government incentive schemes, many vehicles came into the market. So if you see the landscape today, we have almost all types of vehicles on a road. We have 2-wheelers, 3-wheelers, passenger car, buses. There are certain electric vehicles you might have seen on airports or golf cars. So those are not coming on public road. So homologation or testing is not required. But those are also electric vehicles. Those are low speed, high torque electric vehicles. Now coming to the standard under central motor vehicle rule. So these there are group of standards. So there are group of standards for electric vehicles. There are group of standards for hybrid electric vehicles. Then there is a group of standards for retrofitment, like converting older vehicles. There are standards for charging station. There are standards for pilot activity. So like I mentioned, we have Automotive Industry Standards Committee in India under motor vehicle rule. Internationally also, there are various committees like ISO, SE, IEC, SE. They also formulate standards, but those are guideline standards. Those are not regulations. Our AIS is a regulation because it becomes a mandate requirement. In Europe, there is UN under United Nations Economic Commission of Europe is there, and they have a WP29 committee, and they formulate UN regulation. So most of our Indian standards are in line with UN regulations, and they are aligned. Then there is a separate forum. So basically there are 2 international agreements under United Nations. One is a 1958 agreement and another is a 1998 agreement. So India has signed 1998 agreement. So under that there is a global forum for harmonization of standardization, and they formulate GTR, global technical regulation. So in future there will be global technical regulation which will be transport by individual country in their national regulation. So today also there are certain GTRs. We have transposed those GTRs into AIS and notified it. So so you can see there is a global committees who make standards for entire world, where all the countries represent and they give their input, and if it is acceptable to them, then accordingly they formulate their national standard. I think I saw a few messages. There is no audio. Is it clear now?
Sir, your voice is clear. No issue.
Yeah. Okay. There are certain categories of vehicles other than this motor vehicle. So we call it as less than 250 watt vehicle and less than 25 kmph speed. So these vehicles are not registered. They doesn't need a homologation. There is a small testing of power and speed and brake fitment. So it doesn't need a license to run this vehicle. You might have seen this kind of vehicles. So those are exempted category vehicles. And right hand side, you will see there is a special category introduced by the government, e-rickshaw, e-card in 2014. So those are also three-wheelers for passenger as well as goods carrier. Here also there is a limitation on power. The power must be less than 2 kilowatt. Speed must be less than 25 kmph. And these are registered vehicles, but they can ply on specific roads permitted by the local road transport authorities. So local RTOs, they will decide the road for this kind of vehicle being low speed, and there they can ply. So this needs a homologation, but a limited rules are there. And rest, other than these vehicles, rest of the vehicles, there are many standards are available. So there are standards for electrical safety, which is AIS 38, which includes battery safety also. There is a standard called AIS 156 for similar 2 and 3 wheeler for electrical safety and battery. There are standards for electrical energy consumption of the vehicle, that is 39. There is a standard for range, like how much kilometer it goes in one charge. There are standards for motor power. There is a mother standard for AIS 49, how to test the electric vehicle. It gives the detail. And earlier we had a battery standard called AIS 42, which is still used for e-rickshaw, e-cart, but not for car and all, because we have gone ahead with amending this standard. And these are right hand side, you will see these are internationally aligned with UNEC and GTR requirements. Now coming to the battery safety requirement, so why it is important? So for a battery, safety, performance, and durability is important because this will decide the performance of the vehicle. So in order to have more acceptance of this kind of vehicles to the user, we must test battery for the safety, performance, and durability. As I explained, like there are different form factors of cell, like cylindrical or prismatic or pouch, and every form factor has pros and cons. And the manufacturer decides based on the space available, based on the chemistry or the cost of the battery pack. They go with different form factors of the battery. Now coming to the risk involved in a lithium ion, so there is a risk because of the flammability of electrolyte. So because of hotspot or thermal runaway and flammable electrolyte, there is always a risk involved. It's a energy. The electrolytes decomposes and it forms a gas. So sometimes because the temperature increases, the gas formation might happen, which may lead further increase in the temperature. Then such kind of overpressure inside a battery pack may lead to the venting, rupture of the battery pack. So explosion might happen. And that is the reason the BMS and even the charger must have upper voltage cutoffs given so that it should not overcharge the battery, leading some overpressure or venting or decomposition or flammability. These gases are toxic and corrosive. Then exposure of these gases may be a severe harm to the occupant. So these are certain risks involved. If we operate it well within the permissible limits, then it is safe. There are certain solutions also, like non-flammable electrolytes are there. Most of the companies, they use retardant material in between the cells while packaging. They keep sufficient gaps within the cell. They use liquid cooling from the cells to put electrolyte to make the more thermally stable battery pack. There are solid or gel form of electrolytes are there. Some new battery technologies coming. Separator material, as I mentioned, like separator material so as to take out the heat and not to pass the heat from one cell to another. So such kind of battery designs are available. Then there are factors affecting safety of lithium-ion battery. Like BMS is important. The installation of battery pack where you install, like Crestone. So we also do a frontal crash testing on these vehicles. So crash is a mandatory for cars now in India, cars and goods carrier vehicle, not buses and trucks. So these the frontal crash. So we verify that is there any kind of leakage of electrolyte or any kind of fire or drop in isolation resistance. Then we quarantine that vehicle for next 48 hours, because immediately after crash the fire may not happen, but any kind of damage to the cell, lithium-ion cell, might lead a small reaction. So another 48 hours or 24 hours, it might lead a thermal runaway. So where do we install the battery pack, that defines the safety. Then balancing of the cell, like the good BMS will ensure that all the cells are charged properly in a proper, all are at equivalent level. So balancing it does it. So there are certain BMS with active balancing or passive balancing comes. Like for example, if few of the cells are overcharged, it might take the charge from that cell and give it to the less charged cells in order to maintain the balancing. In case of passive balancing, it might discharge that cell through dissipating heat through resistors. Then battery aging also affects the life of the or safety of the battery. Like for example, degradation of the cell. So as you use the cell during the life of the vehicle, because of charge and discharge, there are chances of forming dendrites or small particles inside the cell itself, and those might rupture the separator between the electrolytes, positive and negative electrolyte. There is a separator inside the cell, and the such dendrite formation or burr formation or any impurities in the cell through during at the manufacturing of the cell itself, like metal particles, might create a rupture of this separator, and which creates a short circuit inside, internal short circuit inside the cell between positive and negative electrode, and that will create a hotspot which will lead a thermal runaway, a point of no return, and that thermal runaway might explode one cell, that's a one cell trigger, and which will propagate to nearby cells or entire battery pack. So aging is also important. So many of the OEs, they do such kind of aging test and keep on monitoring the internal structure of the cells, or you can do some, you can cut the cell and monitor what happens because of charge discharge cycles. Then material vented might affect to the passenger, like any explosion might affect to the passenger inside the car. So these are the some of the parameters while designing the vehicle needs to be taken care. So potential hazards in battery EVs. One is a thermal runaway, as I explained, any kind of thing because of, so this, there are some mitigation techniques like management system, like control of cooling the battery pack or proper BMS or maintaining it. There are chemical hazard like electrolyte leakage might happen, which is dangerous. Mechanical in case of explosion or flying parts, and electrical shock because of high voltage, electric shock might happen, and that's why many mitigations are there, like using proper cables, connectors, which are meeting ingress protection IPX6B and IPX60 requirement, putting some symbols on these battery packs or electric circuits where a person servicing these vehicles in a garage will also understand that this portion is a high voltage and he needs to take care, use the proper tools like gloves, or use the proper kind of mechanism to switch off the battery pack and do the servicing of the vehicle. So these are certain mitigations with electric vehicles. Now coming to the battery safety standards. So there are worldwide many standards bodies are there, like ISO, IEC, SE, Underwriters Laboratory, UNEC, USABC is there, United States Advanced Battery Consortium, and AIS is there, Freedom Car. So BIS is there, Bureau of Industry Standard, that is our apex body. So eventually AIS, once it is established and becomes stable, that AIS gets converted into IS standard, BIS standard. But all these standards, they cover basically mechanical abuse, electrical abuse, environmental abuse, and chemical abuse testing of these cells. So such kind of safety testing is there, like for example, mechanical shock, drop, or nail penetration, or immersion, crush testing, or rollover, or vibration, or external short circuit, like suddenly shorting the positive and negative terminal of the vehicle. So sudden electric short circuit will create a high current, and that might damage the battery pack. Or is there any protection used by the designer? Will come to know that. Then overcharging, over discharging, then thermal stability or thermal cycling of the battery pack, like you are doing keeping the battery pack inside a temperature chamber, doing a charge discharge cycle with temperature cycle, overheating, extreme, then flammability, like exposure of the battery pack to the fire. So the most of these standard covers these types of tests, but we use AIS standard for certifying this test, and we have got all these facilities, and all the cell as well as battery pack gets through all these abuse testing, and if they are meeting the requirement, then only certificate is given to the battery pack. Earlier, when we started in 2003, we had a AIS 48 battery standard, which were having only 6 tests: electrical and mechanical abuse, short circuit, overcharge or vibration, rollover, mechanical shock, and nail penetration test. So this standard is now absolute, only used in e-rickshaw, e-cart. Again, there is a update going on e-rickshaw, e-cart. They eventually will AIS 156 standard. So earlier we had two standards, like one was dealing with electrical safety or constructional safety of a vehicle as a whole, like how the vehicle should be constructed, and battery standard was separate. But now we have merged both the standard, and we have a new standard called AIS 38 Revision 2, which has battery as well as electric safety together. And this standard is mandatory, and it notified by the government in 2 phases from December 2022 and 31st March 23. For all the vehicles which are there, car and buses, those are complying this AIS 38 requirement. And there is a standard for 2-3-wheeler, similar standard, that's called AIS 156. And this also deals with electrical safety as well as battery safety in a vehicle. So this is for 2-3-wheeler. So nowadays, all these safety standards ask manufacturers to do DFMA or ASIL level, like functional safety assessment, like risk assessment, and what mitigation they have used, and physical testing will be carried out in our laboratories. Typical test, if you find, as I inform you, it has mechanical abuse, it has fire exposure, it has electrical abuse, external short circuit, it has over temperature, over voltage protection, or hydrogen emission, thermal propagation. So these tests are there in both categories of vehicle. So OEMs or the battery companies, they need to submit us multiple battery pack samples to ARIL lab, and we carry out one by one test on this battery pack. And if it is meeting all the requirement, then the certificate will be issued. There is a conformity of production applicable for these battery packs. Means every once in a 2 year, they have to repeat this testing and ensure that whatever design they are manufacturing, it is still complying the requirement. We amended this standard. You might be remembering some 2 years back, there were certain fire incidents in India, especially in garage or in showroom, or at a home, wherever they are charging during night time. So that time, the Ministry of Road Transport proactively, they formed 2 committees, separate committees. So one were given a task of investigating these fire incidents and root cause analysis, and one committee was asked to formulate safety requirements for amending the present Indian standard based on this exercise. So these committees, along with ARI, did detailed analysis of this accident, and there were experts from DRDO, other ARCI, which are work on electrochemistries, IISc, NSTL, IIT, ARAI, and OEMs expert, and they came up with some additional requirement, and we made a amendment 3 to this standard, and this amendment 3 also got notified. So here the committee gave some additional requirement. For example, the committee asked to test the cell itself. So before putting the cell in a battery pack, they asked to do certain cycling on the cell to ensure that the cell is working properly and it's of better quality. So there is a IS standard of IS 16893. So you need to comply the part 2 and part 3 of the cell. Then there are certain requirements for BMS, like earlier days in low cost two-wheeler, there were no intelligent BMS. Mostly BMS used were certain IC base, which has voltage level kind of cutoff only. No supervisory or microprocessor control was there, which can analyze further and give signals to the OEM. It was a, you can say, passive kind of low cost BMS. But now this committee has mandated it must be microprocessor based. It must have done electromagnetic compatibility safety testing. Certain safety features like top upper limit, lower limit, and overcharging has to be. So these features has to be there in BMS, including data logging, like certain parameters or fault condition must be logged in the BMS. OEMs may push this kind of faults to the server for further analysis, or in case of any accident, such kind of data or black box kind of data should be available for further analysis, like what was wrong if that accident happened. So data logging they have mandated. Then there are certain safety requirements are added for charger also, like whether it's an onboard or portable charger. It must have voltage cutoff or soft start or pre-charge, earth leakage protection, supply variation protection, and it must communicate with the BMS. Earlier chargers were not intelligent, so now there is a handshake communication between charger and BMS. So BMS is always a master, charger operates as a slave. So BMS will tell the parameters to the charger, like how much voltage I need or current I need. Accordingly, charger will be supplying to ensure that safe charging of the battery. Then there are pack level tests additional, like IPX7, water immersion, thermal propagation, high temperature, regeneration protection is there. Pressure vents are mandated nowadays, because in case one of the cell explodes and gas form, the vent will vent out it, and further propagation of thermal or further explosions can be protected. Then temperature sensors are mandated, because of based on this temperature sensor, warnings can be given to the user. Then additional safety fuse as a redundancy mechanism. So inside BMS, inside wiring harness, additional fuses are there. In case of overcurrent, this fuse will protect further short circuit. So such kind of precautions are added as an amendment to both the standards in 2-3-wheeler as well as in car. And a revised approval of these battery packs are done based on this new amendment. So I will not go in this detail. These amendments are already notified one. Now coming to the thermal runaway, we will go in little detail, like what kind of stimuli. So there are certain external reasons why the thermal runaway might happen. One could be the crash of the vehicle, like a vehicle accident or any abusive condition might lead. Thermal shock, like high temperature or low temperature, sudden rise in temperature might lead a thermal runaway. Then there are internal reasons like microscopic particle or impurities, like metal particles inside the cell itself while manufacturing the cell, or slurry of that cell itself. That might lead a internal short circuit, which will create a hot spot and thermal runaway. Then there are other factors like state of charge of the battery pack, which affects the thermal. A high state of charge battery pack will lead a thermal runaway. Then charging discharging rate or cell type, cell history, material, what kind of cathode anode material or electrolyte composition. So all these factors stimulate or lead or may create a thermal runaway situation. So typical thermal runaway detection standard has now mandated. For example, suppose such single cell gets triggered because of this event, it has to be immediately detected by the BMS, and there has to be warning to the user on a dashboard so that the passengers can evacuate the vehicle. And after such warning, there has to be a 5 minutes of window, uh, which within that window there should not be a hazardous situation in passenger compartment of the vehicle. So we do this test. We trigger a single cell in a fully charged battery pack, either by hitting single cell separately, or overcharging single cell, or doing a nail penetration, like penetrating a metal nail inside the cell, like creating internal short circuit deliberately. We create that event and see that whether BMS is able to detect that event based on individual cell voltage monitoring or temperature monitoring, rate of change of temperature, or the dropping of the cell voltage, or any other additional sensor like gas sensor. The BMS has to detect this event, and from detection point of view, 5 minutes we monitor that there should not be a severe thermal runaway which will create a hazardous situation in passenger compartment of the vehicle. After 5 minutes, there might be a fire or explosion, but that 5 minutes will allow you to take the vehicle or park the vehicle and egress out of the vehicle, go away from the vehicle, which will be ensure the safety of the passengers. Now, as a part of this standard, OEM need to do some risk analysis or DFMEA. So they need to find out the areas, the risk associated, the severity, the occurrence, the risk level, then measures taken like mitigation, what design mitigation they have done, like any kind of material, any kind of gap between the cell, liquid cooling, separate kind of technology they have used, and how they have reduced that severity, the occurrence, the risk level, and the plausibility. So we go through the design DFMA analysis and physical testing of the battery. This I will skip. Like globally, there are Japanese and US standards are there. Europe, we follow European standardized, and our standards are in line with European requirement. There is an additional requirement, though it is not mandated under motor vehicle, but most of the companies, logistic companies, while shipping battery pack or cell or vehicles, either by road, sea, or air, they will ask this UN 38.3 transportation regulation certification. So there are certain tests like altitude simulation. If the sail is taken by aeroplane, then the high altitude, how it will affect. So this is applicable not in electric vehicles, any kind of cell, whether it's a laptop cell or any medical equipment. So you need to comply these requirements, and that is the reason when we travel, air travel, they don't allow to keep the cell in luggage area. So they allow it in a passenger compartment where it can be observed. But those all cells needs to be the equipments or components needs to undergo this UN 38.3 transportation requirement. It simulates all these transportation tests. The cell not in use, but during transportation, it might undergo certain severe conditions, and those are simulated in the lab and ensure that the cell is a safe one. Now coming to the hybrid vehicles. So hybrid vehicles, basically it has ICE engine as well as electric motors. That's why there are standards which cover both the portion of electric vehicle related testing safety as well as ICE vehicle related testing, like exhaust emission and all. So we have two standard AS 102 part 1 and part 2, depending upon the gross vehicle weight of the vehicle, like 2-3-wheeler category and cars and buses. So these two standards are there. So based on the logic used in that vehicle, like when and which source of the power will operate, either simultaneously both engine and motor will operate, or motor alone or engine alone operates, depending on these different tests like exhaust emission and electric power tests will be done on hybrid vehicle. So you can see that Hyryder, Toyota Hyryder is a hybrid, Prius is a hybrid vehicle. There are many hybrid vehicles are there. Mostly high-end vehicles coming, high-end vehicles, ICE engine vehicles, which are 48-volt, they are 48-volt hybrid, because to meet the tighter exhaust emission norms, these vehicles have done certain degree of hybridization. Means they have used a motor and battery pack and certain electrification they have done, which gives a grams per kilometer, like CO2 emission grams per emission can be reduced. So most of the vehicles are hybrid in India. Then there is a standard for some pilot activity or small series production also. For demonstration purpose, somebody want to bring certain number of vehicles into Indian road, then we can certify with this AIS 131 standard. Now coming to the retrofitment, I believe there is a separate session for retrofitment, which will be in detail. But we formulated this standard in 2015-16 based on the industry requirement. So older vehicles can be converted, like CNG, LPG retrofitment. Electric or hybrid retrofitment is also allowed by the government. And there are 3 standard, 1, 2, 3, part 1, 2, 3, which covers hybrid and pure elect converter for almost all categories of vehicle. So this is used by many kit manufacturers. They certify their kit with ARAI and they can sell. Individual users can go and convert their older ICE vehicle in pure electric or hybrid. So this is legally allowed by the government. Then there is a standard called electromagnetic compatibility. So all these electric vehicles has high current charge discharge used in this inverters or DC-DC converter. So it might create electromagnetic noise outside. So we need to measure that whether the noise is well below the limit line, as well as if external noise are there, these kind of brushless motors or controllers are prone to immunity issue or susceptibility issue. So we create an external field, modulate it by mobile or FM modulation, and see that under that influence whether that vehicle behaves properly or not. So that's called EMC test. Then in electric vehicle, there are additional phenomena of EMC because such vehicles, suppose you are charging at a hospital, you connected your vehicle in a hospital for charging, and since there is an onboard charger on the vehicle, that power electronics might create a harmonics on a supply line, and that harmonics on 230-volt line or 415-volt line, AC line, which might transmit, and that harmonics on a supply line might create any critical medical equipment which is connected to the patient, which is a life-saving equipment, any ECG or something, which is not designed for such kind of immunity purpose, that might create. So that is the reason there are certain additional tests on electric vehicles while charging condition. If at all any lightning strikes in a rainy season on a substation, so that will create a surge or electric fast tangent, so that will travel to the supply line. So because of that, there might damage happen to the vehicle. So such kind of test simulation we create in a lab with equipment and ensure that this vehicle during charging condition and certain phenomena on mains 230-volt or 415-volt voltage it withstand. So those are additional tests in electric vehicle, not in ICE vehicle. Now, based on the industry demands and the government push, we formulated standards for agriculture electric tractor, hybrid and electric. So these standards are available and notified by the government, and there are 1 or 2 companies who have got certification of their electric tractors also. Then there is a standard for construction equipment, CEV vehicle like bulldozers and all. Those are also coming in coming future will come in electric. Many developed countries, they have started using electric battery pack and motor for this earth moving equipments also. In India also it will come. So we have formulated standard and notified by the government. So any company is interested, they can manufacture and such vehicles and sell in India. Then there is a standard for fuel cell vehicles also, AIS 157. So fuel cell vehicle is also an electric vehicle. So instead of a large battery pack, there is a hydrogen fuel cell stack is there, which will be generating electricity based on hydrogen tanks installed on a vehicle, and that electricity generated will be feed back to the smaller battery pack and in turn to the inverter and motor. So after fuel cell stack. The rest of the vehicle is a pure electric only. So that is why this standard is formulated, and there are some pilot activities going in India. 1 or 2 companies have made fuel cell bus, and some pilot launching they have done. Though it is till a very costly and infancy, but in coming future, this kind of vehicles also will come. But fuel cell vehicles, since it is a electric, also the similar requirements of high voltage safety, traction battery safety, hydrogen safety, and performance tests are applicable. So typically, when a vehicle comes to ARI for type approval or homologation under motor vehicle rules, so we carry out certain verification tests like functional construction tests are there, certain safety testing like electric shock, water effect test like exposing that vehicle to the rain or flooding or washing, garage washing. Because of that water exposure, there are chances of reduction in isolation resistance or electric shock. That also we tested. Then battery safety, frontal crash, EMC. And then there are certain performance testing like range, like how much kilometer it goes, how much energy, what is the energy consumption per kilometer to run, what is the motor power, gradability, max speed, and brake. So once the vehicle meets all these requirements, the type approval or homologation certificate is given to the company. With that, they can manufacture and sell it to the market. There are few new standards are proposed. For example, in the coming future, these are under draft right now, but in coming future, like battery durability monitoring is important, because suppose the manufacturer has come with a battery which is of substandard, and it may not last as per their promises given to the user. So that's why there is a minimum performance requirement, and monitoring will be there. So we will be randomly selecting vehicles from the field and checking that how much of the battery capacity is still available on the vehicle, whether it is degraded than the minimum specified criteria, or before the kilometers running of the vehicle. So such things are very important. So we are formulating this standard based on a global technical regulation, and coming future, this will be a mandatory requirement. So certain kilometers or certain age has to be guaranteed, and the OEM has to meet that requirement. Otherwise, they have to change the battery pack. So minimum performance guarantee will be there. Then there is a standard for electrified vehicle power level requirement, because most of the high-end vehicles are coming with multiple motors, like front and rear motors are there. If hybrid vehicles are coming with multiple source, like ICE with 1 or 2 motors. So in case the entire vehicle power, how to measure the entire vehicle power? So that is defined by this standard at chassis dynamometer. So this is because all the sources may not operate at peak power simultaneously. So depending upon the load condition or demand from the user, individual source, traction motor or ICE will deliver the power. So based on that, this new standard is under formulation now in a draft state. Coming to the charging station or charger, so there are 2 types of chargers, like conductive or inductive charging. So predominantly in India, conductive charging is there, like through cable connection is there. Inductive charging in car, right now it is not there in India. In coming future, it will come. But inductive charging you use normally for your mobiles, like you keep the mobile on a pad and it gets inductively charged. So there is a transformer coils in a mobile, one coil section will be there, and that the charging pad one coil will be there, which will form a transformer or mutual inductance. They will transfer the power. So such kind of chargers are there for electric cars also, but right now not available in India. So mostly conductive charging is used. Either chargers are mounted on the vehicle, which are of low weight, low power, and there are outboard chargers which are of a DC charger, which are fast charger, which is external, and entire power electronics is inside that, which is a high voltage, high power chargers are there, which can quickly charge the vehicle. Onboard chargers are usually small because you are carrying a dead weight always with the vehicle. So those are typically overnight chargers or smaller charger of 3.3 to 7 or 11 kilowatt capacity. So these are in, as I told, in India, we have allowed by the Ministry of Power, they have allowed only type 2 AC charging protocol and CCS2 protocol. Earlier there was a Bharat DC charger also, but nowadays it is no longer in use. So Japanese and Chinese and North American, those are not allowed by the government. The Tesla and other thing, those are proprietary charge connectors. So they need to change once they come to the Indian market. So in a charging station, these are the nomenclature. So infrastructure side, or the equipment which is mounted on the wall or equipment on the floor, that is called a EVSE, electric vehicle supply equipment, because it gives a supply, either AC supply or a DC supply. Then that side, we call it as a socket and plug will be there, because there are sometimes the cable is not connected to the charging station. A loose cable will be used, so it is a socket and plug. And vehicle side, similarly, we call it vehicle inlet, like connector which is mounted on the vehicle is like our petrol inlet is there. So whenever we go to the petrol station, the inlet they will use for filling. So likewise, charging inlet is there, and a charging vehicle connector is called, other side is called vehicle connector. So we formulated this AIS standard initially based on IEC standard in charging station. Since this is an infrastructure site, it is not governed by any AIS and all. These are IEC standards. So based on IEC standard, we formulated AIS, and eventually these AIS were converted into BIS, and those are numbered as IS 17017 series. So all these charging stations which are procured under tenders and installed in public locations are certified as per IS 17017 series of standard. This will skip earlier. Earlier, our ministry has developed a protocol and Bharat AC and DC charger, but which was a low voltage up to 100 volt DC only. But now it is obsolete. Only old vehicles, 2015, some cars were utilizing this kind of charger. So in short, we have standards and connectors or protocols for light electric vehicles, which are 2 and 3 wheelers. Then medium range of electric vehicles, those are passenger cars or goods carrier, like smaller goods carrier vehicles. And we have standards for heavy vehicles like bus or trucks, including a pantogram, like overhead pantograph kind of thing, like a railway which gets connected. So automatic mechanism will be. So all these charging station standards are notified by Ministry of Power, because it comes under the purview of Ministry of Power. And we test those standards, or we test those charges and certify it. But notification comes from MOP, Ministry of Power. So in charging stations also, you will find that there are standards covering varieties of areas. Like there are standards for the connectors, plugs. There are standards for the communication protocol. There are standards for security, safety. So many sets of standards are there, because since these charging stations are connected to the internet for billing purpose, now cyber security is also important, because you can penetrate, or you can hack the charging station and use the wrong billing, or you can penetrate to the vehicle. So such kind of security as well as safety, communication protocol, connectors, cables, and charging station. All these groups of standards are the IEC has covered entire requirements. So there are different modes, they call it. Like some vehicle you might have seen with only coming with a cable with some small box, that is called in cable current protection device for safety. That is mode 2 ICCPD. So charger is always on the vehicle, but you have a cable to connect the main supply to our 3-pin connector. Mode 3 is basically AC charging, like a wall mount charger is there, which is giving a AC. Here also a charger is part of the vehicle, but wall mount EVSE will be there, electric vehicle supply equipment. And third, mode 4 is called as a DC charging, like external DC directly given to the vehicle. So these are pictorial view. Like mode 1 is no longer allowed in most of the countries because of safety, including India. Mode 2 is a smaller cable, Mode 3 could be a wall mount, as well as mode 4 is a DC charger. And there are different cases, like sometimes the cable might be attached to the vehicle, or cable might be completely detached, or it will be connected to the supply equipment or charger, EVSC charging station, which you can connect to the vehicle. So different scenarios are available in the market, which are all allowed. Typically in a charging station, if you see, so it has a controller, it has a HMI display, human machine display, some switch gears are there, auxiliary power or output switch gear is there, and server connectivity like backend. Like all these charging stations are connected to the central charge point operator, where it can find out which charger is working, whether the charger is connected with the car or not, which charger is empty. So based on that, they can have mobile-based application. So a user can find out, I am at particular location, and now what is the nearest location charging station, and how many chargers are empty there available right now for charging. So such kind of applications can be designed. That's why the charging stations are connected to the backend systems. This is a type 2, this kind of connector is allowed, the bottom connector. Then DC charger, in addition to that, it has a power electronics also, which it locally convert AC to DC and supplies directly DC. So this area we will skip. So these are IS standards. We'll share this material, so you will find all these standards, which is published by Bureau of Indian Standards on their website. Then there is a new standard, the Principic Scientific Advisor to Government of India. They advise us to have a formulated standard, which is called, you can say, Kirana shop standard or a small charger. So the idea was any small shop or Kirana shop, they can put this charging station with the minimum available electronics with and Bluetooth connectivity, and any 2 and 3 wheelers companies can charge. Even the connector used was IS 60309, which is normally our home AC has this kind of connector. One. So this is a special standard formulated by us, and it is published by the government. We got the patent also on this. Many companies are making similar kind of charging stations. So these are the standards for DC charging, including CC, CHAdeMO, and Type-C connector. So these are AC type of charging stations. Now, one important concept is there, like battery swapping. So since the charging time is a little bit more, typically for lithium-ion battery for full charging, it might take 4 to 5 years. Of course, the 80% capacity of the battery can be charged within half an hour or 45 minutes based on the C rating used for charging, like 2C, 3C, or even a 6C also can be used. In India, nobody is using beyond 1C. So 1C, almost 80% you can charge with less than an hour, but remaining 20% might take some time. And fast charging also damages the battery pack. So it is not always advisable. But in Europe, there are some charging stations or flash charging stations which can go up to 6C or more than that also. So within 10 minutes or 6 minutes, you can put almost 80% of the battery capacity. And if the battery capacity is large, even almost 400, 500 kilometers range you can put in a vehicle. So this kind of, but instead of that, there is a concept of swapping the battery pack. Like for example, like our home LPG gas cylinder, we get a filled one and we use that filled one gas. There will be some swapping station within the cities, and instead of waiting for a charger charging the battery pack, go to the swapping station, put the empty battery pack in swapping station, get the charged battery pack and put it inside the vehicle and go. So this is a concept in many countries for two-wheelers and three-wheelers. It's popular. Even in China, they have used this concept for buses and cars also. So this is a work in progress. So we have formulated some 3 standards for the connector, for the battery pack, for the communication protocol between battery and charging station. Because here the charge point operator or swapping station will be the energy provider. So the vehicle OEM might sell the vehicle without battery, and you need to subscribe the energy operator to get the charge battery pack, and he might charge depending upon the energy use from the battery pack or depending upon the distance travel. So they fit telematics devices. They will find out every transaction how much energy is used. Based on that, some subscription model will be there. You can charge, you can take a monthly subscription kind of thing. So such models are there outside India. So this is work in progress. The ministry, if they permit this kind of, there are vehicles right now in India using swappable. The only thing is these companies are also trying to get the incentive for this model. But now one or two companies like Gogoro or Honda, they have swappable model in India. In certain cities, they are running this kind of thing. Here, some of the pictures you can see from the China, like they are swapping the entire bus battery pack. Even in India, in Ashok Leyland in 2015-16, they had in Ahmedabad, they have implemented, they have a bus, a swappable battery pack for a bus and a robotic arm which removes the battery pack and put it for charging, and charge battery pack will be placed inside the bus. Then for buses, for high power charging, there are pantograph, because these charging stations, in case of high voltage, high current, the cables and connector will be a bigger one, so handling might be difficult. So there are concept of pantograph, like overhead kind of charging. So automatically bus will be coming under that pantograph, and the pantograph will align itself and will gets connected, and it can start charging through overhead kind of cable connection. So it could be a flash charging for a shorter duration if the bus comes in a docking station, or it could be complete charging of the vehicle depending upon the battery pack. So this here also the charging standard is being developed. We are developing now a technology, and in Auto Expo we will be displaying this technology. And any OEMs are interested, we'll hand over all the know-how so that they can manufacture this pantograph. In charging station, you can see the complexity, how much like the station communicates with the driver, communicates with the charge point operator, it communicates with the vehicle during charging, it communicates with the utility like grid, smart chargers or smart grid is there. Then it can communicate and tell, depending upon the grid load or time load, it will start taking the energy from the grid. So there can be a different billing mechanism to the user depending upon the time of the day. Like for example, if you are connecting the vehicle in a night time for the charging where electricity load will be less, the utility companies like electricity companies might charge you less since you are charging at a peak, not at peak power. Like daytime, the peak load is there. During that, the rate of electricity might be more. So such kind of business models can be done. Even there is a concept of vehicle to grid, like in case of a remote area, for example, where grid or the complete grid is or electricity is not available, microgrids are available. So in case of that, we can have a V2G concept, like vehicle to grid kind of thing. So I will just quickly go through and we will start the question. So we have all charging station facilities. So we have a center of excellence. So we have facilities for motor testing. We have facilities for battery testing, battery health or electrochemical impedance spectroscopy, all abuse test for the batteries. Entire charger test facilities are there. Safety testing of the vehicle. Then we do a lot of development or integration or control development. EMI MC is there. Anechoic chambers are there. CAE is available with ARI. All material characterization is available. Structural dynamics, kind of like simulating road condition in a lab and find out any abuse to the vehicle, and all kinds of reliability or performance testing is available. So I will stop my presentation and will take some questions if at all any questions.
Yes. If anyone has any doubt, they can unmute and ask the question.
Good evening, sir.
Good evening. Good evening. Please go
Yes,
ahead.
you are.
Excellent presentation, sir. Excellent presentation. I had one small doubt, sir.
Yeah.
This Mahindra car B6E electric vehicle.
Yeah.
That has come with some BYD blade batteries.
Hello, sir.
Yeah, blade batteries, correct.
Can you speak, throw some light
Myself,
on
Dr. Manish.
Sir,
Yeah.
please wait. Please wait. We'll take one question at a time. One question is going on. After that, please ask. We'll allow everyone to ask the questions. One question is going on. Sir, please continue.
Yeah, so these are different kind of form factor or module forming technology. So basically, these are a longer length pouch kind of cell. So pouch cells, you are bringing it together and forming a module. So it's I had shown you that that aluminum foil kind of pouch cells are there, but little bigger size kind of. So they call it as a blade cell. So it is in case of uh, prismatic cell, there is a hard cover, but in case of this kind of blade or a pouch kind of cell, the individual cell will not be having that hard cover, but those cells you can put in a plastic containers together and connect it and form a module of, say, how many cells you want to connect parallel, like 2 parallel, 3 parallel, 4 parallel kind of thing, and then you can keep on forming. So it's just a form factor kind of thing, but those chemistries are same, like either NMC, LFP chemistries are there.
Hello.
Yeah.
Yeah. Thanks for a very nice and crisp presentation, sir. This is Dhananjay Vagholikar here. Just couple of points I would request you to shed light on.
Yeah.
First, this Center of Excellence which you are referred at ARAI, the testing facilities for EV activities. Is it possible for a common man to have a look at it with some official arrangement or something like that?
Mostly colleges or engineering colleges or faculty member, they can visit. Actually, we have a business development department, so they can arrange, if the director approves, then they can arrange visit, or any for example, any proficiency improvement programs are there, then we usually take them to the facility to have some kind of exposure, like how we carry.
Common man, can he approach and have a look of the testing facilities?
Only through this proper organized way, either colleges or companies who are doing business with us, or through training. Not any common person can come and see the facility, because all these facilities are engaged for some customer projects which are confidential.
Yeah, I understand that of course has to be taken care of, but the masking those aspects, is it possible to see the testing? That is what I'm trying to understand.
Yeah, correct. If you come through organized way, like as I told you, through college or something, then it can be done. Yeah.
REEES drive. So what is really that? Somewhere in one of the slides you did mention REEES drive or something. So what is that?
So RWSS is just a name for the traction battery. It is called rechargeable electrical energy storage device, storage system. Means it is a abstract level name they have given. Instead of battery, there could be a super capacitors also in a vehicle. So they call it as a RWSS, rechargeable electrical energy storage system. It could be a battery, it could be a battery plus capacitor, it could be capacitor.
टमाटर लो जितना लेना टमाटर ले लो कितना लेना है
Okay, thank you, sir.
मैं भी खाऊंगा यहाँ पर मैं भी खाऊंगा यहाँ पर मैं भी खाऊंगा रोटी लाए ना वहाँ से यार.
Yes, so, someone's mic is on. Please ensure that mic is mute. Anyone has to ask?
Hello, sir.
Yeah, please.
Sir, there are different kinds of batteries you said now.
Yeah.
We do have a charging station. Is that one charging station suitable for charging all kind of batteries?
Yes, it is suitable because the BMS inside the battery pack is a master and charger always works in a slave. So BMS communicates to the charger saying that I need this voltage and this current rate, and charger supplies that. So it is taken care by BMS. So any kind of chemistry, any kind of cell form factor, any kind of battery capacity in kilowatt hour is taken care by the BMS installed into that, which communicates to the charger. So BMS is a master. So any kind of charger can charge it.
Just one more thing, sir. One
Yeah.
second, Nagorika. Of course, with this EV arena, vis-a-vis the BS5, BS6, the overlap is expected to be very, very less because those are IC engines and these are electric vehicles. But if at all, is there any overlap in terms of energy systems between BS6 and EV systems? Any small overlap?
There will be a overlap because see, most of the globally, if you see advanced countries, they have already declared, say by 2035 or 2040, they will not be allowing any ICE engine. So they will be completely transitioning. Likewise, in India also, we have a nationally determined targets, which are the commitments under this COP21 meetings which happen. So India also has decided certain roadmap, like say for one is neutrality and one is completely zero. So it will take time, but the industry is expecting, say by 2047, like 100th anniversary of Indian independence, the every vehicle sold will be electric. But before that, by say 2030 or 2040, almost passenger transport vehicle, commercial vehicles like buses, taxis will be electric only. That is what their projections are there. But most other countries are going ahead with declaring the dates, like by that time they will not allow ICE engine.
What is the role of IUA in this entire transition?
Hello, sir.
You mean to say International Energy Alliance or?
IUA means International E-Vehicle Association.
Not as such. Those are basically, those associations come together for as a sector for presenting their issues to the government. In India, we have SMEV is a EV, but SIAM is also one of the things. So there is it is just to see or put to the government like what challenges are there or how it is happening. Otherwise, there is no other.
Thank you, sir. Thank you.
Hello, sir. Myself, Dr. Manish.
Yeah.
Sir, I want to ask regarding the thermal management of battery in EV. Sir, hello, sir.
Yeah, please. Thermal. What is your question?
So, nowadays we are seeing that there are a lot of fires comes out from the vehicle of EV. So, is there any roadmap for thermal management? Because now not only the motor is running on a battery, there are a lot of luxurious electronic gadgets which are running on battery, which are causing a lot of thermal load on the EV battery.
So that is the reason we amended our standard. Earlier, limited safety requirements are there. Because of this fire incident now, we have added safety. We cannot mandate saying that thermal management or cooling is a mandatory requirement. We will add safety requirements. To meet that safety requirements, OEM has to add a thermal management system. So it is depending upon the capacity of the battery. Like as I tell, two-wheelers or three-wheelers, those capacities are very small, like 2 kilowatt hour, say 4 kilowatt hour. So nobody uses a thermal management. They will use naturally air-cooled kind of battery pack instead of any force liquid cooling. But in cars and buses, forced liquid cooling is used. So thermal management is very much used in high-power vehicles.
So one more thing. So now every vehicle of battery, fast charging is a requirement. Everyone want to charge fast as possible. This is going to cause a lot of heat.
Correct.
And how And how the heat is managed from one cell to another cell in a battery?
Yeah. So in India, nobody has gone beyond 1C fast charger. Even the user wants, the OEM has not designed the battery pack or the charger with more than 1C rate for the charging. So they are really, though even though we call it as a fast charger, they are not really much fast chargers. So everybody goes with, say, to the 80% of the battery capacity, they go with say 0.8 or 1C at the most, and then they taper down the charge. Like they will reduce it to 0.8C to 0.5C, likewise they will reduce. So that much, the reason is being a tropical country and environmental condition, how much heat they can handle during the charging, they have taken care through this C rate. So really fast or 2C, 3C, 4C kind of chargers or the vehicles with such a rate of charging is not available in India. So whatever they can handle in open condition, they have taken care, they have reduced the charging rate. So though they call it as a fast charger, it will be a limited portion fast charging. Then during charging, you rightly said, in vehicle, like for example, wherever thermal management is there, they will take care of cutting off if at all temperature goes. Otherwise, in 2-3-wheeler, there is no cooling mechanism. It is just naturally kept in inside. But if at all in future they come with say 10C charger, then force air cooling will be required. But this aspect can be taken care in swappable battery. Swappable they can do with a higher C rate, and they can have ACs or fans installed in that swapping station, because it is not on the vehicle. You are doing outside the vehicle. There you can manage the cooling in a better way.
Okay, sir. Thank you, sir.
Sir, myself Yogesh Garge.
Okay. We'll take one last question, and because we have next expert in waiting, so we'll take a
Yes,
last
sir.
question.
A very short question. Manoj sir, you said something about converting old vehicles into electric vehicles. So suppose I have one scooter at my home, and if I wish to go for the electric one, so is it possible or is it allowed to convert that electric IC engine vehicle into a electric vehicle, or what modification does ARAI allowed?
Yes, it is allowed, but you need to go to the authorized retrofit kit approved kit company who can do it. Means there are companies who has developed a kit for scooter. They have converted one scooter and given it to you, and we have tested their kit on that scooter. And those type of scooters of those make or those model with that kit, we have permitted them. Only they can modify your scooter and give it to you, and then RTO will re-register it's as a electric motor, because IC engine they will need to remove. You can, if you yourself modified as a vehicle, then you cannot run on public road legally. You can keep it in your premises, try it yourself. That there is no problem. But if you are bringing out on public road, then it has to be through authorized channel only.
Okay. Thank you very much, sir.
Okay, dear participants, so here we'll stop with the questions. Yes.
Can I ask a question, sir?
Yeah.
It's a request, sir, not question.
Yeah.
I want to say, please share the slide with us so that we can go through it in a deeper way.
Yeah. The organizers will share with you.
Yes. Okay.
Can I ask the question, sir?
No, so sorry, sir, but we'll stop because we have to start the next session and we are running out of time. You can mail us the question, organizers. We'll
Okay.
mail this, sir, and that's how we'll answer your query, sir. So thank you very much, Manoj Desai, sir. Through this session, we have gained a deeper understanding of innovations, development, and regulatory standards in electrical vehicles. It has been an enriching experience of learning. So on behalf of organizing team and all the participants, I want to extend our heartfelt gratitude to you taking your time to share this invaluable knowledge and experience with us. Thank you very much, sir. Thank you.
Thank you, sir. Thank you very much. Yeah, I will log out now. Yeah, thank you.
Email ID, sir.
So dear participant, without wasting much time, we'll be starting our session number 2, design and development of battery pack for four-wheeler electric vehicles by Assistant Professor Shweta Patil ma'am.
Feedback form will be solved together.
Feedback form is shared, sir, already. Dear participant, please note that feedback link will be shared throughout the lecture. So you have to be attentive to fill the feedback form, and also will be monitoring your presence throughout the through the WebEx. Understand this is ATAL FDP. Please do not ask for feedback link all the time in the chat box. We'll provide feedback link. Don't worry about that. We want you to get most of the information throughout the session, so you can enjoy the sessions. Feedback links will be posted in the chat box, and attendance will be also monitored through WebEx. Thank you very much. So I'll be introducing our next session expert, Shweta Patil madam, currently pursuing her PhD in the topic of modular development of conventional vehicle into electric vehicle. She has solid experience of 16 years in research and academics. Her expertise spans fluid mechanics, applied thermodynamics, hydraulics and pneumatics, electric vehicle powertrain design, and CFD. She has successfully worked on and completed various industry-sponsored projects and guided many UG students for accomplishment of their academic projects. She has published more than 7 research articles at reputed national and international conferences and journals. She has received multiple fundings. Few of them are rupees 2 lakh from the Packwell Gasket Private Limited India, Jigyasa Fellowship of rupees 2 lakh from PCCOE Pune, and rupees 5 lakh from Zero Research Scheme. So with this introduction, I invite Assistant Professor Shweta Patil madam, and madam, please take over the charge.
Thank you, Shreyas, for this introduction. So let me share my screen.
Just a second, madam.
Just.
Yeah, stop sharing. You can share.
Okay, okay.
The participants who have joined late, please join with the serial number. Serial number is available on the WhatsApp group. Thank you. Yes, madam. Screen is visible. You can go to full screen mode.
Okay. Is it visible now? No?
Yes, yes.
Audible?
Yeah, madam. You are audible also.
Okay. Thank you, Shreyas. So without wasting time, we'll start the second session. So hello all. I'm Shweta Patil.
Sorry to disturb, madam. Just go to full screen mode, madam.
Just a minute. Is it now full screen? Hello, Shreyas?
Yes, yes, continue, please.
Okay. So, hello all. Today, I'm going to discuss the design and development of battery pack for four-wheeler electric vehicle. So, this session is specifically for how to design the battery pack for any type of vehicle. It may be the two-wheeler, three-wheeler, and four-wheeler electric vehicle. Second one, it can be used for this methodology can be useful for the retrofitting option. Suppose you have to design the battery pack for the retrofitted vehicle. So here I consider the four-wheeler as a application or one of the case study to design and develop the battery pack for electric vehicle. So this is the outline of my today's session. So we know that electric vehicle is a booming technology as compared with the IC engine vehicle. It gives a higher efficiency, and the moving components of electric vehicles are very less as compared to the IC engine vehicle. Second one, it is a cheaper to maintain, environmentally friendly and less emission. So because of these key features, electric vehicle is a popular in the transportation section. So what is the battery? We know that electric vehicle has a 4 configuration. So here I only concentrate on the battery electric vehicle. So what is the battery electric vehicle? It is nothing but the vehicle with a motor as a driving unit, which is used powered by the battery with appropriate cell chemistry. So battery electric vehicle, the battery is a energy source and the motor is the power source. So for today's current session, I am going to highlight or concentrate on the traction battery pack, design and development of traction battery pack. So the methodology which I designed for the designing of the battery pack. So this is a brief methodology how to design the battery pack. So basically it comes with the four structure. So this is the first structure. First structure is related with the vehicle dynamics. In case of the vehicle dynamics, we must know estimate the energy consumption with respect to different drive cycle. Second floor or the second part of this particular methodology is the battery type selection. In the battery type selection, we have to select the cell chemistry, proper or appropriate cell chemistry, then cell form factor, then customize or the compact battery pack. Third structure is the once the cell chemistry is there, then go for the pack designing. Once the pack designing is over, and then go for the pack development. So here my session is up to the pack development, how to design and develop the battery pack. The testing, I will just highlight the what are the different testings required for the battery pack for any specific application. So we'll start with the first step, that is a vehicle selection. So actually, before starting the designing, we have some system requirement. Suppose you have to design the battery pack. So first of all, vehicle section is very much important. Vehicle section is nothing but the categorization of the vehicle. For what type of the vehicle you want to design the battery pack, whether the two-wheeler, three-wheeler or the four-wheeler application, you have to first categorize. Second one, what type of the trip are you expecting from that? Suppose it is a four-wheeler, then it is a city drive, highway drive, rural drive, urban drive. So that driving condition needs to be considered while designing the battery pack. Third step is nothing but the vehicle performance. Vehicle performance is nothing but the what type of the top speed of the vehicle, then acceleration of the vehicle and the gradient of the vehicle. So vehicle performance needs to be considered while designing the battery pack. Then available space in the vehicle. Suppose you are designing the new electric vehicle, so you have to check the space availability, and in case of the retrofitting, what is the available space for the your battery pack. So space availability is one of the constraint in the designing of the battery pack. Then the range, expected range. For example, some user want a 100-kilometer range, some people want the 200-kilometer range. So from that point of view, you have to design the battery pack. Suppose you require the high range, then the battery pack cost will be more, because the battery capacity and the power of the battery pack will be more. So it will be hamper on the cost of the vehicle also. Next one is the charging time. Whether you want a short charging time or the long period charging time, that is 6 to 8 hour, then 4 to 8 hour, and last one is the 3 to 6 hours charging time. So you need to consider the charging time while designing the battery pack. And last component, that is the weight of the battery pack, because the weight is also one of the key factor which is hampering on the performance of the vehicle. If the vehicle weight is high, battery weight is high, so it will give the less range or the very short range. So weight of the battery pack needs to be considered while designing the battery pack. So this is the system requirement. Before starting the design, you must go for the system requirement. Then the vehicle selection. So here in this session, I am going to discuss the one case study which is related to the four-wheeler vehicle. So I have selected the Maruti Zen as a forward wheel drive manual 5-speed transmission as a test vehicle. So some vehicle data is required for the vehicle dynamics analysis. So that's why on the left side of this particular slide, so you can observe the vehicle data. So what type of the vehicle data is expected here? So the dimensions of the vehicles are required. Then you need to calculate the frontal area of the vehicle, then the clearance of the vehicle, then the total weight and the gross weight of the vehicle. Here I consider this is at the top speed as a 16 km/h. Then tire size is required, aerodynamic drag coefficient and density of the air is required. So this is the vehicle data. This vehicle data is required for the vehicle dynamics analysis. So today I am going to discuss the analytical approach. Actually, in battery pack designing, there are two approach. First one is the modeling or the simulation based approach, and the second one is the analytical based approach. So here I am discussing the analytical. So while selecting the vehicle, so here I selected the smaller lighter vehicle. The space requirement, considering the space requirement, the age of the vehicle, chassis structure, and the city drive. Here I am assuming that this vehicle is a city drive passenger car. So from that point of view, I am going to design the battery. I will show how to design the battery pack. Once the vehicle selection is over, then go for the second step, that is a vehicle dynamics. Actually, the vehicle dynamics plays a major role in the sizing of the e-component. It plays a major role in the motor or the powertrain sizing as well as the energy storage sizing. So vehicle dynamics, that is nothing but it is a principle of vehicle dynamics which assert that resistance as a counter force to impedance the motion of the vehicle. Actually, there are four type of the various forces. First one is the rolling resistance force. So rolling resistance force is nothing but the force that resists the vehicle motion on the road surface. So it can be calculated with this analytical CR/mv/g cos theta. So what is the CR? CR is nothing but the rolling resistance coefficient between wheel and road surface. So it is depend upon this coefficient is depend upon the tire material, tire structure, tire temperature, road type, then pressure, geometry, road roughness, road material, and the presence or absence of the liquid on the road. Second one is nothing but the aerodynamic force. So aerodynamic force, as we know that when vehicle is running at a certain speed, so we may experience a force that resists its motion. So that force is known as a aerodynamic force. So aerodynamic force is influenced by, first one is the vehicle speed, second one is the frontal area, then the shape of the vehicle and the density of the air. Third type of the force, that is nothing but the gradability or the gradient force. So the gradient force is related with the when the vehicle is moving on the hilly region. Okay, so in that case, that force is nothing but the gradient force. So the theta is nothing but the gradient angle. Generally, this angle varies from 2 degree to 18 degree. Okay, so normal in case of the Maharashtra, so normal grade angle is a 2 to 4 degree, but in the hilly region, it will goes up to the 14 or 15 degree. Then the inertia force, we know that the inertia force is related with the acceleration. Okay, so it can be calculated with the acceleration time. So the total tractive force, so total tractive force is nothing but the it is the combination of all the forces, that is a rolling resistance force, aerodynamic force, then the gradient force and the inertia force. So this total tractive force is required for the estimation of the energy consumption as well as the sizing of the battery pack or the sizing of the powertrain. So the vehicle dynamics plays a major role in case of the sizing of the battery pack. Once the vehicle dynamics is over, then we go for the energy consumption. So we need to find out the energy consumption for per kilometer. So it is required to find out the total energy required for particular range. So energy consumption, the accurate and the correct energy consumption for the electric vehicle is quite essential. Why it is essential? Because battery capacity, battery chemistry, then the size of the battery, electric drivetrain system, size, battery weight is completely dependent on the energy consumption per kilometer. The energy consumption, it is related with the driving range of the vehicle. Means driving range of the vehicle is completely rely on the energy consumption. So energy consumption needs to be accurate and the correct energy consumption is required, because your battery pack will be means designing will be based on the energy consumption. What happens, suppose you the estimation is the lower energy consumption. So in that case, what happens? So size of the battery or the capacity of the battery will be lower. So it will pay hamper on the range. So range will be the shorter. If the energy consumption is more, so in that case, what happens? So the size or the capacity of the battery will be the more. So we'll get a more range, but it will be hamper on the economy. Economy is nothing but the cost of the battery will be the more or the higher. So that's why it is very much essential to estimate the energy consumptions per kilometer. Actually, how to calculate the energy consumption? There are two ways. I already discussed that that is a simulation based approach is the one of the approach which I am going to discuss in my next session. And second one is the analytical approach. So both the cases drive cycle plays a major role. So drive cycle analysis, here I am going to discuss the drive cycle analysis. So what is mean by the drive cycle? Actually, the drive cycle is nothing but it is a set of vehicle set versus time. Means at particular speed and at particular time, what is the speed of the vehicle. So driving cycles are generally constructed to determine the performance of the vehicle through the fuel consumption. Basically, before the electric vehicle, the drive cycles are used for the estimation of the fuel consumption for the conventional vehicle, petrol and the diesel vehicle. But now in case of the electric vehicle, same methodology is using, that is a drive cycle based energy consumption. So it is used in the both the cases, conventional as well as the electric vehicle. So the drive cycles are designed, means actually the constructed drive cycle, and there are two types, constructed drive cycle and the standard drive cycle. So I'm going to use the standard drive cycle here. So constructed drive cycle is nothing but that it is constructed as per the real driving conditions. But the standard drive cycles are designed in such a way that they can be used in any type of the vehicle, irrespective of real world operating condition. There are number of type of the drive cycles available. Some of them I consider here, that is WLTP drive cycle, then NEDC drive cycle, then FTP drive cycle, HW FET drive cycle, UDC drive cycle, IDC drive cycle, and MIDC drive cycle. So these drive cycles, actually the selection of the drive cycle is very much important while estimating the energy consumption. So here I consider the MIDC drive cycle, then NEDC drive cycle, and HW FET drive cycle. So NEDC drive cycle, so NEDC drive cycle is nothing but it is a new European drive cycle which is created to monitor the fuel economy and estimate the emission level of petrol and the diesel vehicle. You can observe the speed plot of the NEDC drive cycle. So NEDC drive cycle is the combination of two drive cycle. UDC is nothing but the urban drive cycle, and the EUDC is nothing but the extra urban drive cycle. So it is a combination of urban drive cycle and extra urban drive cycle, which is revised by 1997. Most of the time in Europe and other countries are following the NEDC drive cycle as a reference cycle for the Euro 6 norms. Some companies are also preferring the NEDC drive cycle. What is the main objective or the goal of the NEDC drive cycle is to calculate the energy consumption and range of the petrol and diesel vehicle. But now it can be used for the petrol vehicle also. So in case of this NEDC drive cycle, what is the major highlights of NEDC drive cycle? So the total distance or the duration of the NEDC drive cycle is 1180 seconds, and the total distance covered by this drive cycle is 11 kilometer, and the average speed maintained for this particular drive cycle is 33.6 kilometer per hour. So this much is the drive cycle speed as well as the time profile. So it will run 1180 seconds, and the total duration is the 11 kilometer. So it will be means vehicle will face the all the road operating condition during this 11 kilometer. Second drive cycle is nothing but the HWAPT drive cycle, that is nothing but the highway fuel economy test drive cycle. So this is the this drive cycle is created by the EPA, that is the Environmental Protection Agency, which is created three regulation drive cycle, that is FT drive cycle, US drive cycle, and the HWFET drive cycle, which is used for the speed profile and the emission measurement. So highway fuel economy drive cycle, so it is actually it is driving on the schedule conducted on the chassis dynamometer. So this drive cycle is specifically for the highway drive cycle, means high speed drive cycle. So total duration of this drive cycle is, you can observe that it is a 765 seconds, or roughly it is 13-minute drive cycle, and the distance covered is a 14.43 kilometer. The average speed achieved for this particular drive cycle is the 77.7 kilometer per hour. So this drive cycle is specifically or applicable for the highway driving condition. And the last one is in case of the Indian condition. So in case of the Indian case, there are two drive cycle. First one is the Indian drive cycle. So IDC drive cycle, which is first created by the ARA in 1985 by the Central Motor Vehicles Rule. It is created to address the pollution control on the vehicle in the country. Actually, you can observe the IDC drive cycle. So its duration is very less. It is 108 seconds, and the total speed, that is average speed, is the 21.9 kilometer per hour, and its distance is near about 8 kilometer. So what happens in this particular short distance period? So all the vehicle doesn't meet the all the road conditions and the vehicle requirement. So that's why it is not feasible. It is a specifically used for the two-wheeler and the three-wheeler application, but it is not for the four-wheeler application. So that's why new drive cycle is created or by the ARI, so developed by the ARI, that is MIDC drive cycle. So MIDC drive cycle is the modified Indian drive cycle. Modified Indian drive cycle, which is by specifically for the four-wheeler automobile and the light commercial vehicles, that is M1, M2 category vehicles. Okay. So MIDC drive cycle protocol implemented in 2000 and enhanced with the improved cold start testing methodology. So MIDC drive cycle is similar to the NADC drive cycle, which includes the maximum speed of 90 kmph, and the total distance is the 10.8 kilometer. Okay. So this is total duration is the 11.08 second. So considering this drive cycle, so drive cycle plays a major role in the estimation of the motor as well as the battery sizing. So the energy consumption per kilometer is obtained from the drive cycle. So I consider this drive cycle for current analysis. So by comparing the energy consumption, why the energy consumption is high? Basically, there are number of parameters which is affecting on the energy consumption. So what are that parameter? First one is the driving mode is also important. Then the driver's behavior, driving style is important. Then the quality of road as compared with the rural road, urban road, and the city road condition. Then uncontrolled traffic condition, frequent start stop, then type of the route, whether it is a micro route, and the mini route. So these are the parameters affecting on the energy consumption. So automatic ARI has released the standard method to test the driving range. So this is for the M1 and M2 category. So our vehicle comes in that category. So considering the Indian driving condition and drive road condition, I have selected the MIDC drive cycle. So here this is the comparative analysis of the energy consumption. So the energy consumption, initially we have to calculate the energy consumption. So energy consumption, for calculation of the energy consumption, what is required? The vehicle dynamics, that is a vehicle speed is important. Then the rolling resistance force, then the aerodynamic force, inertia force, gradient force is required, acceleration time is required. By considering these all the parameters, we can analytically calculate the total energy. So this total energy divided by the distance of the drive cycle is nothing but the energy consumption per kilometer. So from this analysis, the energy consumption per kilometer for MIDC, HW, FET, and the NEDC drive cycle is accordingly 68.99, 64, and 98.92 watt-hour per kilometer respectively. So I consider the MIDC drive cycle considering the Indian road condition. So this investigation of this drive cycle, so energy consumption per kilometer for MIDC is 24% and 29% higher than the HWC. So energy consumption for the MIDC drive cycle is high because due to road condition and the type, rural road requires the more energy as compared with the city and the highway roads. So energy consumption through MIDC drive cycle has been considered for the further battery pack analysis because of the Indian road condition. So this is the major steps at designing of the battery pack, that is energy consumption per kilometer. Once the energy consumption is over, then go for the next step. So next step is the battery selection. So Manoj sir is already highlighted the various types of the batteries used in the electric vehicle. So commonly used batteries in electric vehicles are lead acid battery, lithium ion battery, nickel cadmium battery, nickel metal hydride battery, and the sodium nickel battery. You can observe here, this is nothing but the battery chemistry chart. So which is related with the energy density and the volumetric energy density and the specific energy density. So the energy density, you can observe here the lead acid, nickel cadmium, nickel metal, and lithium ion battery. So lithium ion battery has a higher volumetric energy density and the specific energy density. So that's why it is a lighter in weight and the smaller or the compact in the size as compared with the lead acid battery. So second one is the while selecting the battery type, we must consider the sum of the performance parameter. We know that the lead acid battery is widely used in the automotive applications and it is used in the used as a backup power source. But lead acid battery has energy density is very less as compared to the lithium ion battery. Second, power density is also very less. So what is the energy density and in the power density? So energy density is nothing but the amount of the energy stored per unit volume of the battery, and the power density is nothing but the amount of the power delivered per unit of weight of the battery. So power density and energy density of the lead acid battery is lower. Then the operating voltage is also low, self discharge rate is also low, and the energy efficiency is also low as compared with the lithium ion battery. Second one is the nickel metal hydride battery. So nickel metal hydride batteries, these are commonly used in the portable devices such as cameras and cordless phones. They have a higher energy density compared to the cadmium batteries, but this is a more environmental friendly nickel metal battery. But in case of the energy efficiency and the operating case, so this is the lithium ion battery gives the better result. So lithium ion battery, lithium ion chemistry has a higher energy density, power density, as well as the operating voltage. Then the self discharge rate is less as compared with the other battery, and the energy efficiency is near about 90%. So that's why it is a good player. Lithium ion batteries are a good player in case of the electric vehicle. It is used in the other applications also. Because of the compact size and the lighter weight, lithium ion chemistry is popularly used in the all the electric four-wheeler application. In the three-wheeler application, two-wheeler application, also lithium ion batteries are used, but in three-wheeler application, some vehicles, that is auto rickshaws, electrical, using the lead acid battery. But the weight of the lead acid battery is very high as compared with the lithium ion. Once the battery chemistry is there, then go for the cell chemistry. So next step is the cell chemistry. We have selected the lithium ion battery because of its excellent key features. So in lithium ion, there are also 6 chemistries. So lithium cobalt oxide, lithium magnesium oxide, lithium nickel magnesium oxide, lithium nickel cobalt aluminum oxide, and lithium iron phosphate oxide. So these are the different chemistries used in the category of the lithium. So lithium cobalt oxide, cobalt oxide has a high specific energy compared to the other batteries. It is a preferred choice of laptop and mobile phone, but it has low specific power and the low safety and the low lifespan. Second one is the lithium manganese oxide. So the specific energy cycle and the durability at the high temperature is very less in the lithium magnesium oxide. Then the thermal runaway temperature is up to the 250 degrees centigrade. Then lithium nickel magnesium oxide. So its cycle life is more, but the thermal runaway temperature is 210 degree, and durability at the high temperature. Durability is nothing but the behavior of the battery at a high operating temperature. So it is very low. Okay. So the next one is the NCA, lithium nickel cobalt aluminum oxide. So it has the thermal runaway temperature is 150. And as compared with all the chemistries, so considering the thermal runaway, durability in the high temperature, cycle life, and the specific energy, the lithium iron phosphate is the means gives the more key feature, more stable characteristics. So that's why lithium iron phosphate cells are popularly used in the battery packs in the electric vehicle. So what are the selection criteria for the cell chemistry? Actually, this is the cell chemistry criteria. So first, that is nothing but the specific energy is one of the criteria. Specific power is the another criteria. Then the safety is the third criteria. Performance is the fourth criteria. Then the total cycle life or the life span is the fifth, and the cost is the sixth criteria. So with comparison with this case, specific power is nothing but the highest possible power per mass of the battery. So this feature of the battery chemistry and packaging is the specific power. So it determines the weight of battery needed to reach the specific performance goal. Second one is the energy. So energy power or energy density. So it is nothing but the nominal battery energy per unit volume. Then the power density, that is the highest power possible per volume. Then the performance is nothing but the operating performance of the battery. So operating performance, that is nothing but the wide operating range, just like a lithium ion phosphate. So its operating range is -20 to 60 degree. So this is a wide operating range as compared with the NMC battery and LCO battery. And next, very important, that is the cost of the battery. So cost is nothing but it should be the optimum cost available. The cell should be available in the optimum cost. So considering all these parameter, lithium iron phosphate cells gives the better results as compared with the other. So NMC is the most of the players vehicle manufacturing also using the NMC batteries, but the operating temperature range of the NMC battery is short as compared with the LFP battery. It is minus. So second one is the temperature is affecting on the NMC battery. So strong thermal management system is required for the NMC. But in case of the LFP, so LFP thermal runaway is at 270 degrees centigrade and the operating range is -20 to 60. So that's why the LFP gives the better result as compared with the other from cost, performance, lifespan, safety point of view. So cell chemistry selected for this particular battery pack is the LFP cell chemistry. Once the cell chemistry is over, now next step is we need to check the cell form factor. So what is the cell form factor? Cell form factor is nothing but the shape of the cell. Actually, in the battery pack, Manoj sir highlighted the different shapes of the battery cells. So there are three type of the battery cells shapes: cylindrical battery cells, prismatic cell, and the pouch cell. So the characteristics of these cells are different. So we'll check one by one. So cylindrical cells are robust. These cells are less expensive, equal distribution of the internal pressure, and good mechanical stability. So these are the key features of the cylindrical cell. So these cells has a long calendar life. Then it is economical, and it has low packaging density due to the space cavity. Suppose you have to design the battery pack, that is a customized battery pack. So in that case, for the customized battery pack, generally the cylindrical cells can be used. Why cylindrical cells are used? Because in that case, we can create or develop the customized battery pack for the different capacity. For example, suppose I need to design the battery pack or develop the battery pack for the 144H or 150H. So I will assign or join the cells 50 in the series and the parallel combination. So it will be exactly that. But in the second case, prismatic battery, so prismatic cells are the improves the space utilization and allows the flexible design, but it can be more expensive to the manufacturer. Then the shorter cycle life, no space cavity for the cooling, and the swelling problem is the one of the problem in the prismatic cell. In case of the prismatic cells are available in the high capacity as compared with the cylindrical. But in case of the customized size, so in that case, the customized battery pack is not possible, or it is difficult to develop the customized battery pack. Next one is the pouch cell. So pouch cell is nothing but it offers the simple, flexible, and lightweight solution to the battery design. It has a soft case, but it is a more expensive, short cycle life, and it is not suitable for the sharp edge corners, because its case is not a hard case, so it is a soft case. So in that case, there may be the chances of the cracking. Then it will achieve the 90 to 95% packaging efficiency as compared with the other type of the cells. So considering this point of view, here I need to design a customized battery pack because the space availability for the battery pack is the major constraint in this particular case study. So that's why cylindrical battery pack can be used up, because we can develop the battery pack from the floor battery pack as well as the cavity or the flat battery pack. Okay, or any shape of the battery pack is possible according to the availability of the space. So cylindrical cells has been selected for this particular case. In case of the one cylindrical cells are selected, in the cylindrical cells, again the cell configurations are there. In case of the market analysis, so there are three type of the cell configuration. So what is the first cell configuration? That is 18650. Second one is the 26650. Third one is the 32700. So what is the 18650? So first two digit is the diameter, second two digits are the height of the cell, and O0, that is nothing but the cylindrical. So these three configurations are available in the LFP cylindrical combination. Now the question is, which cell configuration is the best for this particular case study? So here 32700 cylindrical cells has been selected. So I will show you why this cells is selected for this particular case. So in this case, here, so comparative analysis has been carried out for this particular case. So 1865, 21700 and 32700. So the supplier for this case 18650 is popularly used in the electric vehicle, but 32700 is also using. The suppliers here Samsung and HXL. The chemistry is the same. So what is the nominal voltage here? 3.6 and 3.2. But the capacity of the cell here, you can observe that 1865 cell capacity is 2.5 Ah, but the 32700 its capacity is the 6 Ah. Actually, if the capacity is high, so in that case number of cells required for the battery pack will be the lower. If the capacity is very less, then the number of cells will be more. If the cells are more, the weight will be increased. Then the second one is the size will be increased. Second one is the nominal cycle life. So 32700, it provides the higher cycle life. So this cycle life, actually the cycle life is considered in the two cases. First one is the 100% depth of discharge and the 80% depth of discharge. So this cycle life is considered at the 100% depth of discharge. So what is mean by the one cycle life? One cycle life is nothing but the one charge, one discharge. So that is nothing but the one cycle. So 3000 to 500 cycle lives. So lithium ion HX cells has been selected because of the high energy to weight ratio, then the fluctuate capability to function at elevated voltage and low self discharge rate. So from that point of view, the 32700 cells has been selected. The next step is the market analysis. So in case of the market analysis, here different manufacturers are considered for this 32700. In that case, so the cost is the one of the parameter and the energy density is the another parameter. The nominal voltage is the same for all the suppliers. So here from that point of view, so HX cells are available at 200 to 180 to 200 rupees, but the Panasonic as well as the FBTech cells are costly. It is 250 rupees per cell. So from cost economy point of view, the and second one is the energy density point of view. HX 32700 3.2 voltage 6 Ah cells has been selected for this particular battery pack. Now the cell selection is over. So the major steps in the battery designing is the cell selection. Second one is the battery chemistry, and the third one is the energy consumption. Once it is over, then calculate or the estimate the total energy required. So that is nothing but the energy consumption into range. So initially we can assume the range. So here I assume the 100 kilometer range as a intercity drive point of view. Then the battery capacity is nothing but the total energy by battery voltage. Actually, for this case, the 48 and 72 volt is the and 96 volt was the option. So this is the light commercial vehicle. So that's why the battery voltage has been selected as a 72 volts. Then number of cells in a parallel combination and the series combination. So here the battery capacity is 144 Ah and the cell capacity is 6 Ah, and so that's why the 24 cells are series parallel, and for the series combination battery voltage is the 72 volt and the cell voltage is the 3.2. So from that point of view 24 cells are required in the series combination and the parallel combination. So total number of cells is nothing but the parallel multiplied by the series. So total number of the cells is required for this particular battery pack is the 576 cells. And then the battery power is the voltage that is nothing but the capacity into volt, and battery peak power is nothing but the peak voltage and the peak current. So this is the pack details for me. So after this is the pack specification. Okay, so cell selection, lithium ion cylindrical 32700 LFP cell has been selected. Drive cycle analysis, NEDC, HW, FET and MIDC drive cycle. So battery capacity, in case of the battery capacity in voltage 72 volt 144 Ah. Then the battery power is nothing but it is near about 10.36 kilowatt hour battery pack. Then the battery cell number of cells in parallel 24, cells in the series combination 24, and total number of cells are the 576. So this is the pack details. So during the development of the pack, so pack voltage is the 72, but the peak voltage is the 76.8 volt. Then the battery capacity is 144 Ah. Pack power is the 10.36. If you consider the peak voltage, so the power will be the 11.05 kilowatt hour. So here the discharging current is less than 200 RPM and charging current is less than 300 RPM. Then the series cell. Okay, so here only one model. Actually the battery pack is nothing but it is the combination of a number of model, but considering the available space, so the available space, active available space for this particular case study vehicle is the 540 by 750 by 160. So that's why the pack size, the series and parallel combination has been selected in such a way that so it will be in a floor pack. It is not this is in a flat battery pack. It is not a floor pack, and the number of module is the single module. So this is the battery pack specification for the particular case. Once the battery pack is over, then there must be considered the feasibility check for the battery thermal management system. As we know that if you consider the battery pack, so battery pack is the combination of cell, module, then battery management system and battery thermal management system. So feasibility check must be there before designing the battery thermal management system. As we all are aware about that, the battery thermal management system is required to obtain the optimum battery temperature. That is nothing but it is a 15 degree to 40 degree centigrade. But in case of here, some feasibility study has been carried out to check the impact of environmental condition on the battery pack and the impact of different discharge rate on the battery pack. So that's why the experimental study has been carried out for the feasibility check. So during the market analysis and the battery pack manufacturer's observation, so LFP battery pack has a longer operating temperature. So it is -20 to 60. So it doesn't require the strong external cooling system because of the long operating range. But to check this case requisite of the cooling system and the impact of winter and summer season on the battery pack temperature, so it is investigated through the experiment. So small experiment has been conducted to check the feasibility of the battery thermal management system. So dummy battery pack has been created or developed for this feasibility check. So it consists of the 3 by 6 battery cells. The battery cells, 3 cells are without the cooling thermal insulation, and the 3 cells are wrapped with the thermal or the potting material. This is the experimental setup. So different operating condition has been considered. So operating condition is nothing but the seasonal condition. What is the effect of the winter condition on the battery pack? Then the summer condition and extreme high temperature condition. So these three temperature conditions has considered for this particular study. Then this is the cell with the casing. So this is the dummy battery pack. Then the battery discharger. Why the battery discharger? Here second study is also considered, that is the impact of the discharge rate on the battery temperature. As Manoj sir highlighted that in the Indian condition 1C rate is sufficient. That is absolutely right. Actually in the vehicle condition what happens, the discharge rate is the 1, 2, 3C rate. But when the vehicle is running, vehicle never run at a constant discharge rate, that is a C rate. Means vehicle never run at 1 C rate continuously for from start to stop. Then it will not run at constant 2 C rate or the 3 C rate. Actually 3 C rate condition is applicable when the vehicle required more power and the more acceleration point of view. But normally vehicle can run at a 1 C rate. So from that point of view, different C rate is also investigated. So from this experimental analysis, what we observe that, so if the cells are wrapped with the thermal insulation material, that is a potting material, then the cell temperature never increases beyond the cell specified range. That is a with insulation condition, cell temperature is always within the safe limit at the higher C rate. So for this experimental condition, we consider the constant C rate, 1 C rate, constant 2 C rate, and 3 C rate condition. But in the practical condition, vehicle never face this condition. It is a combination of 1, 2, and C rate, but maximum case vehicle always face the 1 C rate condition. So what is the outcome of this particular experiment? So in this case, external battery thermal management system is not required for particular this condition. So, because LFP cells operating temperature is 60 degree, and when we discharge the battery cell continuously at the 3 C rate, so what we observe that the temperature of the battery cell is up to the 55 degrees centigrade, which is the optimum within the operating range. What happens if the cell temperature beyond the 60 degree temperature, then it will be affect on the performance of the cell. Means cell degradation, then the life of the battery, then the thermal impact. So this will be happen or the occurs only when the cell temperature is beyond the operating range. So impact of the thermal condition, here we consider the temperature as a 50 degrees centigrade. So in that case, the with the insulation material, so the temperature of the battery cell is up to the 56 degrees centigrade or 58 degrees centigrade. So that's why the strong cooling is not required for this particular battery pack. But in case of the other battery pack, suppose you have selected the NMC cell, that is nickel magnesium cobalt oxide cell. So its operating range is a slightly short as compared with the LFP. So in that case, the cooling system is required. So the cooling system, battery thermal management system, is totally depend upon the operating range. Second one is the operating vehicle driving condition. Okay, if it is continuously discharging at a high discharge rate, then the heat generation rate will be the higher. So cell temperature is up to the safe limit at the higher C rate with the use of the thermal insulation material. So that's why the battery thermal management system is not designed for this particular case, or this is a specified case. Then once the designing is over, then the development is the another step in the battery pack development. So battery pack development, it consists of a different component. So you can observe here, cell is the one of the component, then the spacer, then the bus bar, then the gasket, epoxy sheets, and the thermal insulation. The cell is nothing but it is the energy storage device. Then the spacer. So for the optimum cooling or the point of view, the spacers are designed. So the space between the two cell we can set as a 2 mm, 3 mm, 4 mm. Suppose the battery thermal management system is required. So in that case, the space between the two cell should be the 2 mm. Okay, because the 2 mm gives the optimum result as compared with the 3 mm or the 4 mm. So here I use the 2 mm battery spacer. Then the bus bar is nothing but the when we select connect the cells in the parallel combination and the series combination. So in that case, the nickel strips are used. So then that nickel strip is nothing but the bus bar for that the connection purpose. Then the gas kits are also used at the top of the cell. Then the epoxy sheets are also used. So the epoxy sheets are generally used from the adhesive point of view. Second one is it will protect the battery from the vibration or the damage point of view. And the thermal insulation sheets. So thermal insulation sheets we use here, that is a potting material as a potting material from for the protecting the battery from the extreme ambient condition, extreme hot condition. So these are the battery pack. So I will show you this is the design steps or development steps of the battery pack. You can observe here, this is a 576 battery cells which are connected, 24 connected in the series combination and 24 in the parallel combination. So it is a floor to floor battery pack. So yellow color, these are nothing but the epoxy sheets, and the black color sheets are nothing but the polyurethane foam of a 5 mm polyurethane foams is used for this case. And last one is the battery pack casing. So here the battery pack casing is used. This is the final battery pack for the particular test condition. So once the development of the battery pack is over, the next step is the testing of the battery pack. Actually, I will discuss here only what type of the testing is required for the battery pack, but I will not show you the actual testing result of this particular battery pack. So in case of the pack testing, so there are 4 type of the pack testings are required. First one is the mechanical testing is required. In a mechanical testing, what type of the mechanical testing is there? So first one is the vibration test is required. The vibration step is nothing but the which stimulate the real world mechanical vibration in vehicle or the equipment to evaluate the mechanical stability. Second one is the shock and the impact test. So this resilience to physical shocks and impact. Then the drop test is also very important. So drop test is nothing but it assess the pack safety and structural integrity after being dropped. Okay. Then second one is the abuse testing. So this testing is nothing but the overcharge testing. Then the short circuit test, penetration test, and the crash test. So crash test is nothing but the pack resistance to external compression force. Then the penetration test is required. So this test is nothing but the pack's behavior when physically penetrated by a nail or other case. Then short circuit test. So it evaluates the pack's response to electrical short circuit. Then the overcharge and over discharge test is also required or mandatory. It stimulates the extreme condition to test the pack safety mechanism, means battery management system protection. Then the thermal testing is very much important. So in the thermal testing, thermal shock test is required. So thermal runaway shock test is nothing but the thermal runaway test. So which evaluate the pack response to over temperature conditions to access this pack safety. Then the environmental testing is very much important. So what are the environmental types testing? So environmental testing is the temperature, that is a humidity test. So humidity test, that is which is to evaluate the pack performance across the range of temperature, means -20 to 60 degrees centigrade. Then the IP protection test, that is IP, that is nothing but the ingress protection test, which is related to the dust and the water, that is IP67 and IP68 standards. Then the next one is the electrical testing is required. So electrical testing, it can be at the initial phase before the development of pack. That is a capacity test. Capacity test is nothing but the ensures the pack meets the rated specification. Suppose the 144 Ah capacity battery pack, so that is a capacity testing. Then the life cycle, then internal resistance test. So cell internal resistance can be checked because which impacts on the efficiency and heat generation. Then the efficiency, that is energy losses during the charging and discharging, that is also one of the tests. Then SOSIS testing. So SOSIS testing is nothing but the state of charge testing, which evaluate the accuracy of the battery management system in estimating the battery pack SOC. So these are the different pack testings are required after the development of the pack. Actually, what happens in case of the, if it is a customized battery pack, so some testing can be at the suppliers level, that is thermal shock, then humidity, IP test, then electric test can be at the supplier's end. But if it is a mass production, so in that case, the mechanical and mechanical testing has to be testing should be conducted at the agencies, or the testing, different testing agencies are available in India. So through that testing agency, the user needs to check the battery pack, that is a mechanical shock test, a drop test, vibration test, immersion test. So these tests should be at the standard agency. And after that, once the certification, we get the certification, then we can use that battery pack for the actual condition. So this is related with the battery pack development, design development, and the testing of the battery pack for the four-wheeler electric. So here this is for the four-wheeler, but for the two-wheeler, so your vehicle dynamics will be changed. What is the what vehicle dynamic change? Your weight of vehicle will be changed, your speed will be changed, then your frontal area will be changed. From that point of view, your energy consumption will be changed. And if the energy consumption is changing, then your capacity of the battery pack will be changed. Same thing in case of the three-wheeler, but the methodology for the designing of the battery pack is same. So this is the analytical approach. I will show you the one Excel sheet for how to find out the energy consumption for the just a minute, I will show you the analytical case. Is my screen visible here? Hello?
Yes, ma'am. Yes.
So this is the analytical approach to calculate the energy consumption. So here, this is the
Madam,
NEDC.
PPT is only available. We can see your PowerPoint presentation. We cannot see.
Okay, so I need to exit from that now.
Yes, yes. Because I think while sharing, you have selected the options of PowerPoint presentation.
Just a minute. Actually, I'm facing the problem how to exit from
Madam,
that.
you can stop sharing first of all.
No, it is not visible at my end. Just a minute. Yes. Now I'll share this. This is the, now is it visible? Is this visible?
Yes, madam. Data is visible now. Excel file.
Now this is the NEDC drive cycle. So NEDC drive cycle is nothing but it is a time and velocity. So these values, these time speed sequence or the set is standard for the NEDC. So here this is the distance. Then with respect to the here, so it is dV by dt. Then inertia force, then rolling resistance, drag. This is the total tractive force, power, then energy consumptions per total energy required. Okay, and last one is for the particular case for 0 to 1 second, 1 to 2 second. Actually this time step is 1. Okay, but in some cases in the IDC drive cycle time step was a 5. So in that case your distance while calculating here, that is a distance, so you need to consider the time step. Okay, once that is over, then go for the energy consumption. So in that case you can consider the actual current plus previous. Okay, so you will get the total energy consumption. Once the total energy consumption is there, so this is very lengthy sheet because this NEDC drive cycle is near about 10 kilometer. So you can observe here, so this is nothing but the energy consumption. Okay, total. So divided by the distance, that is 10.87. So this will be the 87.56 is the energy consumption per kilometer. This is for the Zen car. But if you want to change the car or the change the vehicle category, so your what we can say that your mass will be changed. This will be totally changed. That is rolling resistance, aerodynamic, then the inertia force. This will be changed. So your energy consumption will be changed. So that is the major difference. So once the energy consumption per kilometer is known, so you can go for the sizing of the battery pack. So this is the analytical approach. In case of the simulation approach, so same thing we need to means we have to upload the drive cycle in case of the simulation, so it will be behave like a real life condition. So this approach, the base of the approach is the same with the help of the drive cycle. So this is regarding the design and the development of the battery pack. If you have any doubt or any questions, you can ask me, because I think it is 9:12. Shreyas, is this okay? Shreyas, sir.
Yes, yes, ma'am. We can start with the questions. Participants, you can ask questions one by one. If you have any
Thank you,
questions.
madam. It was nice presentation.
So good evening, ma'am.
Hello, sir.
Ma'am, in the recent electrical vehicles, there is a problem, ma'am. In the recent electrical vehicles nowadays, we are seeing the batteries are going to be burning out. That is the reason, ma'am. How can we overcome the infrastructure regarding the electrical vehicles? Why can't we go for solar powered electrical vehicles to overcome the charging problems?
Okay. Actually, sir, in case of the electric vehicle, so the that is a temperature related problem. So the cell chemistry plays a major impact in that case. Cell chemistry is nothing but the what type of the cell is used. That is lithium ion. I already discussed. That is a 6 type of the cell. So we need to must consider the operating range of the cell. In case of the NMC cell, its operating range is short. So what happens when the vehicle is running at a high C rate, continuously at high C rate? So the temperature of the cell beyond the operating. So in that case, what happens? Heat generation takes place, and due to the heat generation, what happens here initially? After the 40 degree or the 50 degree, so cell degradation. But immediately the firing or the thermal runaway will not take place. If you see that the thermal runaway, so it is when the temperature beyond 200 degrees centigrade. So in that case, the fire can catch. But in the normal case, what happens if it is a continuously running at a high temperature? So after some cycle, some period of the time, then the degradation will be takes place and the cell life will reduces. So that is the case. So while selecting the cell chemistry for hello.
Electrical system, ma'am. In the electrical system, we are having fuses. We are having the circuit breakers. Why can't you are going? Why can't we are not going for that circuit breakers and fuses to protect the vehicles from the short circuits or heavy, high thermal actions?
Yeah. That is because of the thermal runaway is only when or the short. So I already told you that in case of the battery pack designing, while designing the battery pack, some testing needs to be required. That is a short circuit test, then the thermal runaway test. So that is the one thing need to be considered while designing or developing the battery pack. Hello.
Ma'am, why can't we go for go for the universal battery system, ma'am? If you are making the universal battery system, we may avoid the charging problems.
So actually, this is this is related with the design and the development. So charging here, I consider the charging is the level 1 charging for this particular battery pack. Level 1 charger is nothing but its capacity is less, and it can be charged at the home place also. So that is the case.
Hello,
madam.
Last
Yes,
one,
sir.
ma'am. Last one, ma'am.
Can I speak, madam?
Yes.
I request participants to go one by one and ask one or two questions only. Let everyone ask the questions, please.
I have one doubt, madam. In aerospace, aerospace,
Sir, your voice is
do
breaking.
you
I
you
think
hear my voice?
two people are speaking.
Yeah, I request only Sujit Chaudhary sir to first come with the questions. Others, please wait. Sujit Chaudhary sir, please continue. Sujit Chaudhary sir. Okay, next.
Hello, sir. May I speak now? Ask
Yeah,
question.
sir, go ahead, go ahead.
Sir, ma'am, you have shown regarding the pack component. So which are basically playing role in the thermal management mostly. A spacer
No, sir.
is playing a role.
Spacer is for the keeping the space between the two cells. The spacer in market 2 mm, 3 mm, 4 mm spacers are available. So what is it mean? The distance between two cell is 2 mm. So spacer is for the isolating the cells. That is a splitting the cells. So that is the spacer.
No, ma'am. If the distance if the distance between the two, the thermal management will be more, the isolation will be more, but the size of the battery will be increased. That effect.
Actually, what from the literature point of view, if you check the cases, so in that case, actual practical cases, so what happens if the spacer size is more, that is space between the two cells is more than the 3 or 4 mm. So what happens? Suppose it is a air cooling, so it is completely strike from the inlet to outlet. So the inner circulation is not possible. Second one is the size of the battery pack will be increased. Suppose you are working on the compact size and the space availability is the one of the constraints. So in that case, the 4 mm, it requires the more size also. But in case of the 2 mm, from number of literature or the investigation, so 2 mm is the good combination. Good combination is nothing but the suppose it is a air cooling system. So in that case, the air will be passed through that as compared with the 4. But in case of the liquid cooling system, so liquid cooling system, we cannot directly strike the liquid on the particular cells. So different channels needs to be designed. So it may be the inner side at the top side or the bottom side of the cell. So in that case, the spacing can be varied as per the requirement of the battery pack. But for the air cooling system, here I consider the 2 mm from that point of view.
Thank you, ma'am. One more question.
Yes, sir.
Regarding the testing. So you have shown various testing for the battery pack testing.
Yeah.
Is there any international standard has been made or regulation has been made for this testing, the standard procedure?
Yes, sir. Suppose you have to commercialize your battery pack or any commercial application. So you need to do the certification from the standard agency. I think Manoj sir highlighted the standards, AIS standard 1, 2, 3 standards like this. So you have to first develop the one battery pack and you have to do all the testing for that battery pack through standard agency. Means just like ARI or other standard agencies are also there for doing the testing. And after that, once you get the certification of that testing, then you can use that in the commercial or the regular application. Without testing, you cannot do that in your case.
And one more, I want to just request, please share your slide is very nice. So please share to us so that we can go in deep understanding.
Yes, sir.
Hello.
Thank you, ma'am.
Thanks.
Hello.
Wagulikar sir, go ahead.
Thank you for a very nice presentation in a step-by-step manner. Couple of points. One, I will request, if possible, if you can share your presentation.
Yeah, definitely.
In case there's some data is not shareable, we can understand that, but the remaining part, if you can share, that will be better or full. Secondly, I think you referred about the epoxy sheet. Correct me if I'm wrong.
Yes. Epoxy sheet, I use it.
Along with the protecting the battery pack from shocks.
Yes.
What are the other purposes for which it is used?
No, actually what happens in the epoxy sheets and the thermal insulations. So these are generally used from the safety point of view. That is first one, it will be work as a adhesive like this in the battery cell, and second one is a sudden drop or the hammer or the damage of the battery pack. So in that case, cell remains protected. So that
protecting
point of
from
view,
mechanical damage mainly.
yes, mechanical damage. Yes,
Okay,
mechanical safety point of view, sheets are used. A different thickness can be used as per the user's convenience.
But then that also increases the overall battery pack volume size. I mean, to be accommodated in the vehicle.
Actually, sir, the sheet thickness is 1 mm, 2 mm, and 3 mm. That is the case. And
there is
second
scope
one,
for
epoxy potting material thickness is maximum thickness is 5 mm. Above that we cannot do. Okay. So the total distance from the casing to battery cell is near about the 10 mm. That is a maximum distance from cell to casing.
Okay.
That is.
Hello.
Thank you.
Hello.
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 Ah, yes.
Ma'am, good evening, ma'am. Your presentation is very good.
Thank you.
Ma'am, actually, in the commercially, there are 3-wheel e-rickshaws only are there. Why can't it be a 4-wheel? I could not find any 4-wheel e-rickshaws. Is there any restriction from the government?
No, in case of the 3-wheeler, so certification is easy because in the 3-wheeler, what is the maximum power or the speed? So speed is near about the 25 km/h, but in case of the 4-wheeler, it will be more. So below that, certification is not necessary. But if the speed is more than that, so certification is not necessary. The speed
If you
of
maintain the speed less than 30 km, if you maintain the speed less than 30 km, then can we make 4-wheeler rickshaw for family? For
Yes, sir. Oh, sorry.
For example, ma'am, if you want to make a like a 4-wheel rickshaw for a family with less than 30 km speed, then there is no need to take any certificate from the government.
No. ARI certification is not required. If the speed is less than 25, sir, not 30, 25. So certification is not required for that. But in case of the passenger car, its speed is high. So in that case, you must have a certification.
Ma'am, the last thing, already I converted my bicycle into electric cycle. I did my own. Now, can I couple, if I make a two cycle, and if I convert into a electric 4-wheeler car, one, then should I take any permission from the government?
Yeah. The speed limit is the one of the criteria, but other criteria are also there, because if it is a retrofitting, so the rules for the retrofitted vehicles are different. That is nothing but the weight should be, then stability should be considered. That is, weight should not be increased. 17% weight increase is acceptable in that case. So we need to check the certification point of view.
Okay, ma'am. Thank you.
Any other question, anyone?
Sir, one question. Ross, ma'am. Hello.
Yes, sir.
Hello.
Ma'am, why we are going for hybridization, ma'am? Hybrid vehicles. Why can't we go for only pure electrical vehicle? Why we are depending only on some more vehicles are depending on the hybrid vehicles? That is a question.
So actually, suppose you want to convert the complete IC to electric vehicle, fully electric vehicle. So in that case, the cost parameter is higher as compared with the hybrid. Second one, in case of the hybrid case, what happens? We need to consider only the secondary battery and the secondary power source, that is a motor. So capacity rating or the sizing of that particular component is less as compared with the complete or fully electric vehicle. So that is the one of the case, and the emission can be reduced up to some percentile, but in the electric vehicle it can be 100%. But the cost economy point of view is the one of the reason behind that hybridization. The second one, in case of the second thing, suppose you have to completely convert from IC to EV, so you need to change, remove all these things, that is a IC, that is a power source needs to be changed, then the architecture needs to be changed, and you have to design the architecture, separate architecture for that case. Means location of the battery, then because the capacity of the battery will be more. So in that case, the location or the position of the battery and the motor. So architecture needs to be redesigned. So that is the one of the concern from that case. In case of the hybridization, we can directly. Yes.
Can I ask you a question, please?
Yes, yes.
First of all, thank you so much for a wonderful session, ma'am. Just I wanted to know about, the battery disposal or waste management system.
Okay. So,
Can you be more specific about your question, sir?
So battery disposal, sir, actually some R&D work is going on in this particular, but there is no any standard methodology or the standardization for the disposal of the batteries till now.
Okay. Thank you, ma'am.
Sir, we'll take the last question for now.
Yes, sir. Yes, sir. If there is any, we'll take one last question. Anyone? Okay. So thank you very much, Shweta Patel, madam, for wonderful insights on design and development of battery pack for four-wheeler electric vehicles. It was indeed a wonderful and knowledgeable session. So on the behalf of organizing team and all the participants, I would like to thank you for this session and taking out your time to share invaluable knowledge and experience. Thank you very much. All the participants.
Thank you, sir.
Tomorrow we'll be having again couple of sessions. Session number 3, Innovation in Electrical Vehicle Transmission System by Dr. Praveen Kale, and session number 4, EV Dynamics, Handling Stability and Performance by Dr. Devanand Singh Dev, sir. So again tomorrow we'll be joining at 6 p.m. sharp. I request all the participants to ensure that you know all the instruction now. Please ensure that there will be less disturbance throughout the session, and please keep yourself mute. Thank you very much for your patience listening, and thank you very much for the wonderful support to FDP Day 1. And with this, I declare that Day 1 is over. Thank you very much. Good night, everyone.
Excuse me, sir.
Yes, ma'am. Yes.
Sir, we are unable to fill the feedback for session 1 as it was in the mid of the session. And then we filled it for session 2, but it was the feedback for session 1 is closed now. It is not accepting the responses.
But actually, you have to understand that there are guidelines for ATAL FDP. So we'll be sharing the feedback form, and at the same time, we'll be also monitoring attendance through WebEx. So
I have attended the whole session. You can check my attendance.
Yeah, no issue. That's what I'm telling, madam. If by any chance you have missed the feedback form, don't worry about that. We have recorded the sessions, and that's attendance will be considered. But ensure that throughout the next session you'll be completing the form, because feedback form will be open for 30 to 40 minutes only. After that, session 1 feedback will be closed and session 2 feedback will start. Okay.
So, sir, please share the form once the session is over, because during the session it's very difficult to handle 2-3 things now.
Yeah, madam. Okay.
Hello. Yes, sir. I do agree that also I could not find that.
It is very difficult to find the link because there are number of messages on the chat box.
Yes, sir.
I absolutely agree, madam. That's why I'm requesting all the participants to do not post unnecessary messages. Sorry, but do not post unnecessary messages. Your names, good morning, good afternoon. So those who are attentive, they are getting disturbed. So this kind request. We know you are in the session. No need to write good morning, good afternoon, and your numbers. You just attend the sessions, and please allow organizers to post important messages only. For day 1, we'll consider. Shortly, we'll let you know about the feedback link in our WhatsApp group. Okay.
Sure, sir. Thank you.
Hello.
Sir, I request you, sir, please share to this session slide so that we can go through tomorrow morning.
Yes, sir. We'll be asking the expert, and once experts will share the slide, we quickly share slide with the participants. We'll ensure that before the last examination, all the presentations are shared with you.
Because at the last session, we can't go through the slide. Just I'm requesting you, sir, as soon as.
Yes, absolutely, sir. Absolute, sir. We'll provide as early as possible, sir.
Okay, sir. Thank you, sir.
Sir, if no more questions are there, we can conclude. Raskar sir.
All
Okay,
the
sir, can we
yes,
close
all
the
the
meeting?
queries are answered. We can close the meeting. Yes, sir. Yes, sir.
Close. Okay, Raskar sir, please close the meeting.
Yes, sir. Yes, sir.